Big data technology is in demand. So yes, we are here for a certain purpose. The purpose is to learn big data. The big data is a huge market now, but apart from being a market, it is also a platform. So when you say that we want to learn big data, it is not a single thing that you're going to learn. It's not a single skill that you're going to acquire. It is a platform-oriented skill that talks about administrating, Hadoop-based solutions, ETL-based solutions, a lot of pre-processing based solutions, a lot of machine learning, data science technologies, a lot of in-memory data processing, a lot of batch mode data processing, a lot of data storage, a lot of data lake processes, a lot of NoSQL databases. So big data is an actual bundle of huge amount of technologies, tools, and platform automation stuff. Altogether, we call this as a big data ecosystem. Yes, our time is not sufficient for understanding each and every module of it. We are mostly focusing on the Hadoop part. So our discussion, our everything that we're going to talk about in the next 30 hours would be mostly focused on Hadoop. Rest of the things, yes, there are different courses available in Edureka. You can enroll yourself and complete the entire ecosystem, learning about different tools. But as of now, we'll be focusing mostly on the part of Hadoop. All right, so with this, we'll start the session. So normally, guys, first question that everybody asks me when I go into any conference, when I go and talk to any of the classes, most of the people talk about something and they ask me the first question, what do you mean by big data? We have been hearing about big data, and big data is booming in the market. There are so many things happening in big data, but what exactly is big data? How do you define big data? I start normally the sessions with a story. And the story is like this. In ancient days, people used to travel from one city to another using horse-driven carts. So there was no buses, no trains, of course. People used to travel from one city to another using horse-driven carts. Now, it was pretty okay with people for traveling shorter distances, because the person has to sit on that horse cart, and then the horse is driving from one city to another. Pretty okay. The solution was okay. People were pretty happy. But as time, went through, people started to build more cities. The cities were, quite, separated out from each other. The distance were huge. And most importantly, people grew, people's families grew. So using a single horse-driven cart, traveling from one city to another, a far-off place, and carrying their luggages and their families was a huge challenge. Because a horse-driven cart couldn't basically have that amount of power to drag an entire family with their luggages over a long distance. So it was becoming a challenge as time flew. Traveling through a longer period of time became a challenge. So a lot of people started thinking about how to solve the challenge. How do you solve a challenge? So one guy said, let's try feeding and grooming the horses more. So we will basically groom the horses more, feed the horses more, so that the horse can grow out to be big and strong. Now tell me, guys, do you think no matter how much you can feed the horse or groom the horse, can the horse grow out to become an elephant? Can it be possible, guys? Do you think it's possible? Arvind says no. Vijay says no. Sandeep says no. Obviously no, right? It's a totally correct discussion. No matter what you do, no matter how much you groom a horse, no matter how much you feed a horse, it can never grow out to become an elephant. So there was another guy. He said, okay, hold on. Now there is another solution that I can provide. So instead of one horse driving the cart, let's have 4 horses driving the cart. Now if 4 horses can drive the cart, definitely the horse cart together can go 4 times the better distance, carrying 4 times the better luggage. So do you think, guys, instead of 1 horse drawing the cart, if we have 4 horses or 8 horses drawing the cart, it can be a viable solution in solving a problem which is associated with traveling with huge amount of luggages over a long distance. Do you think it is a viable solution? What do you say, guys? Arvind says no. No, and Prashant says yes. It is right. It is right. If you have only cars, and I'm not talking about discovering something new, but yes, if you have only horses, then instead of 1 horse drawing the cart, 4 horses drawing the cart will definitely solve your problem, right? It's a solution that anybody can build up, and this is exactly what big data says. Big data says, no matter what happens in this entire world, no matter what you think about, you can never ever create a machine, you can never ever create a server, you can never ever create a infrastructure which is so big that it can handle any amount of data and any amount of processing capabilities in this world. No matter what you do, no matter what kind of architecture, no matter what kind of infrastructure you buy out, it is not possible that one single server in this world can fit all your enterprise level data and enterprise level processing. So the solution is, instead of you buying a very, very expensive one single machine, instead of you putting all your eggs in a single basket, instead of you throwing away huge amount of money in procuring one single server, which anyways will not be able to help you, the solution is to buy commodity hardwares, to buy hardwares which are not expensive and combine them together and join them together in such a way that they work together in tandem like a horse-driven cart. And this is what Big Data Solution provides. Big Data Solution says, instead of you going and buying expensive hardwares, instead what you do is you procure commodity customer based hardwares, connect them together in such a way that they can work in tandem, they can work together, they can work as a single unit, and all those machines which are tied together, they can basically solve your business problem. Now if you have 10 machines connected together, you'll have 10 times better processing capabilities and 10 times better storage capabilities. So big data says any kind of problems which cannot be solved because of the limitation of today's existing hardware in terms of storage or in terms of processing can be solved by combining a different set of machines together in such a way that they can solve same problems together. And that is what is called a big data solution. Big data is nothing new. Big data doesn't try to do something that has never been done before. Big data is not a silver bullet. It doesn't try to solve a problem which has never been solved before. The only difference is, in today's world, we see that people are getting restricted by the hardware capabilities with respect to storage, with respect to processing. Big data says, do not worry. It is a problem that we cannot grow our hardware beyond a particular problem. But now with big data, you're not supposed to create hardware. You're not supposed to create servers which can help solve your problem. Instead, we can have all the hardwares or commodity hardwares combined together, join together, and try to solve the problem by working together like a horse-driven cart. So this is what a big data is all about, trying to solve problems by working together in tandem, working as a cluster, and the clustered set of solution is called a big data solution. There are different ways of solving big data problems. One of them is Hadoop. So we are going to talk about big data where we say that we're trying to solve problems. The problems are still the same. We are not going to search gods. We are not going to search God particles. That's not exactly what big data does. Big data does the same thing. The same problems that we face till now, you're going to face the same problem tomorrow. The only difference is, now with the moving time, your data is huge, your processing requirements are huge. So big data says your existing problem, which has become huge because of the limitations of storage and limitations of processing, can be solved by using a big database solution. So big data is nothing but connection, collection, and accumulation of a lot of commodity hardwares working together in tandem. Make sense, guys? Does this story inspire you? Vijay says, can these hardwares be a simple desktop? Obviously, yes. You can have desktops. People, there are different ways of talking about a desktop. In today's world, you have i7 processors with 32 GB RAM as desktop. So yes, you can even have lesser amount of machines working as, working as your part of the cluster. So yeah, absolutely yes. All right. So guys, any questions till now? What is big data? Are you getting a feel of what is big data? Interesting things. Yeah, so mostly guys, I do not like actually to talk about these slides. It doesn't excite me. The slides are pretty boring. For me, it's all about experience, sharing the experiences, sharing the stories. That's how you remember things. All right. So do you want to listen to another story, guys? Another one, better? Yeah. All right. Okay. So the second question that normally people ask me is, we understood what is big data. Second question is, people are saying that everybody wants to have a piece of big data. Question is, what kind of problems does big data solve? We understand, okay, that because of the limitations of the hardware stack, because of the limitations of processing and storage capabilities, now we are talking about not buying a single server and wasting our money, but buying a collection of commodity hardwares and connecting them together to work in tandem to work for our solution. We get it. We understand what big data is. It's all about divide and conquer. It's all about working together. But what kind of problems does big data solve? Can big data solve let's say can big data help me find something that I've never done before? So what kind of problems does big data solve? So for this, I have another story for you. So imagine, guys, that all of you are the managers of some bank. All right. So hear this story, guys. So you guys are the managers of some bank. Now you'll ask me, if you're the managers of some bank, why should you be coming here and listening to the story? But anyways, imagine that. It's the imagination. Imagine that all of you are the managers of some bank, and your bank tells you to do a business study or come up with a decision to identify the best possible place to set up an ATM. All right, you getting it, guys? The question: you are the manager, you have been given the responsibility of searching the best place to set up an ATM in your city. All right, so where do you set up a ATM, guys? If you are the managers, what will you do? Most populated place, Yusuf says. Well, for me it will be easy. I'll open it in front of my house so that every time I go out, I'll withdraw some cash. Probabilistic answer, good one. This is a solution that will help me. But as a manager of the bank, I'm not supposed to take decisions that's going to help me, right? So I have to take a calculated, rational decision. So guys, can anybody tell me, if you want to take a rational, calculated decision, what is the most important thing you need? What kind of, so in your life, and forget about the ATM, in your life, what is the thing that you think about, or what is the thing that you want, so that using that you can make a decision? What is the most important thing you search for before making a decision ever, in a personal life, professional life, whatever decisions you want? Arun says analysis. Yeah, analysis, a certain fact. Muhammad says facts. Yes, yeah, facts. But how do you identify facts? Subhash says information. All right, information is good. Yes. What else? Past statistics. Yeah, okay, I agree to that. Yes. But even more, how do you get all this? How do you analyze the statistics? How do you find out the data? RNA. Oh, right. Okay. So what else, guys? Something else. All this stuff requires something for you to do. I mean, you cannot just do an RNA. You cannot just do an analytics. You cannot just do a statistic analytics on anything. You need to, for a decision, you need to first market research. Yes, you need to collect data, right? So you have to have data. Everything you said holds absolutely true, but for doing all those stuff, you have to collect the data, right? First thing ever to make a decision is to get the data. If I have the data, then I have a base to make a decision. Do you agree with me? The most important first step for me is to get the data. After I get the data, I can do all the stuff. Absolutely right. Okay. Now imagine that I have the data. So what I have to do is to identify the data. So I, as a manager, I go to my analytical team and I'll tell them that I want a report identifying the best place to set up an ATM. Now the analytic guys, they'll have to think about a process which can help them make that report. For making that report, they have to collect data. So somebody says, how do you collect data? So somebody says, okay, let's do one thing. We have a database in our company. The company's database is built out of Oracle. That database talks about all the customers who are based out of this city and their zip code. So one particular source of data would be my internal database, which has customers zip code. So that is one particular set of source of data. Somebody else might say, all right, so why not go and look into the customer care logs? I'm sure a lot of people will be opening up their chats, live chats, and discussing about lack of ATM to the customer care executive. So you'll have a lot of log files where people are chatting in free-flowing text, chatting about the lack of ATM in a particular location in the city. So it can be another source, right? The customer care logs. Somebody says, so why not, the telephone logs? Somebody might be calling the customer care and talking about the lack of ATM. So why not the audio files? So audio files can be your source of data, right? Somebody says, okay, great. Why not go and search the Twitter? I'm sure a lot of people will be complaining about the lack of ATM in a particular location and hashtagging our bank, and we can basically search or data mine, or basically, let's not go into technical words, but search for all those tweets where people are complaining about the lack of ATM. Somebody says, why not open up a portal? Anybody who wants to log into our net banking, they'll be getting a small form and they can fill up the form and we can get where people want an ATM. So somebody says, why not basically go and spread out the leaflets? Somebody we will just give some leaflets and ask people in the bank to fill out those. And later on, will basically somebody have data entry this into our system. So net guys, the idea is when you start looking into the data, it is not only the data that is available in your own database. The data that is available in your own database in your company is not even the 10% of the data that you can find out in your entire world. If you want to make a decision, if your decision has to be correct, if your decision has to be rational, you cannot just think about making the decision based on 10% of the data which is saved into your rational database. You have to think about the other sources of data, like the audio data, the free-flowing text data, the social media Twitter data. All the data are equally important. So what you do is to find out all those sources of data. Now, great. You have identified sources of data. Now, the analytics team, they will say, hey, we have identified some 7-8 different sources of data, but what kind of technology, what kind of process can help us co-locate all the data together in a single platform? Do you think Oracle can hold up audio data, video data, log files, and free-flowing text, guys? Do you think Oracle can handle this kind of multi-layered data? Muhammad says no. Vijay says no, absolutely not. Is there anybody who can do that, as you know now, right now? Shrija, Mohit, everybody says no. All right. So as of now, nobody does that. But you have to use that data. You have to think about a platform which can offer you that kind of a setup where you can dump any kind of data. So somebody says, all right, I've heard about Hadoop. Hadoop does that thing for us. So let's implement a Hadoop-based solution. Why? Because Hadoop is the only platform which can handle any kind of data. So we'll start set up a Hadoop platform, and then all the different sources of data will collect the sources of data and dump the data into our Hadoop platform. Absolutely great. So okay, so the analytic team, they think about this and they said, okay, perfect. We'll use Hadoop. We'll store the data and we'll identify all the sources and we'll dump the data neatly into our Hadoop platform. Somebody says, but storing the data, loading the data is not important enough, right? Because at some point of time you have to have a 360-degree view of the data. You have to look into the data collectively, holistically. Even though the data is coming from different sources, you have to basically combine, merge, massage the data in such a way that your decision has to be based on all the data together. So there has to be some processing framework. Now again, the analytical team guys, they say, okay, Hadoop is not only for data storage, it also provides you with a processing framework. So whatever you're thinking about, you'll have data coming from different sources. There'll be different variety of data, but Hadoop can handle it. We can handle different kinds of data and move the data into a single platform. We can extract the important information from all the sources of data, and we can create a small repository where the data is coming from different sources but unified. Right? Now, once you have those unified data, you can easily process the data and get out a report saying that, okay, maybe ABC is the best location to set up an ATM and XYZ is the next best location to set up an ATM. Once you get the report, you send it to the manager, which is us. Once we as managers get a report saying that, okay, based on the analytical team, ABC is the best location and XYZ is the second best location, then we can make a strategic decision, maybe based out of a lot of things. We can think about setting up an ATM in that location. So do you guys get it, guys? This story, does it inspire you? Does it tell you what kind of problems big data is trying to solve? So big data, net in this story tells you two things. First thing is, big data is not trying to solve business customer focusing solutions. It is definitely not a customer focusing solution. Second thing, what we are learning from this story is big data is all about using the data to make a business decision. So any kind of business decision, because of the volume of the data, because of the different channels of the data that we have thought about, we might have to think about Hadoop as a platform which can be used for storing and processing it. So first thing is, it is definitely not a customer focused technology. Second thing is, Hadoop is all about batch processing. It is all about making a business decision. It's a business oriented technology. It is not a technical solution that you're looking for. It is a business solution that you're looking for. At the end of the day, the output of the Hadoop system is to help make you correct decisions in your business front. And that is what big data is all about. Big data tries to solve a business problem by giving you decisions which are rational. Make sense, guys? Any questions till now? This story, simple enough, good to understand. Clear? Mohammed says all clear. Okay. Okay, Tulasi says, what kind of source is allowed in big data? Well, anything under the hood, everything is allowed, but we'll definitely see into and look into more data later on. But as of now, it's just a data storage layer. You can store any kind of data. That's the bottom line, and that's the truth statement. All right. So Vijay says interesting. All right, guys. Okay. So all clear, guys. Are you guys getting happy about this class? And guys, anytime you feel like, you can always raise your hands and drop me a text and say, man, you need to move in this way. You can always help me understand how should I move ahead and talk about in this class. Because guys, as you might have been knowing, there are a lot of people in this class, and all of you come from different backgrounds. For me to identify the best possible way to discuss is, I cannot understand that unless and until you guys tell me, right? I do not know whether I should be talking more about stories, more about technicalities. How do I move ahead? So please guide me, guys. I need it. All right. Tulasi says, I have one more question. Shoot, Tulasi, just key in your questions. Do not have to ask for anything. Anytime you feel like having a question, guys, just key in. Sometimes I might get late on answering the question because I'll be discussing a topic, but I'll definitely come back to your question. Okay, so key in your questions as much as you want. Srija says, why Hadoop is more popular rather than Spark and Talent? Well, very premature to answer this, Srija, honestly, because Hadoop is a platform. We'll see what kind of platform Hadoop provides us. Spark was a separate platform a little while back, but right now Spark comes under Hadoop. Honestly speaking, Spark comes under Hadoop. Spark and Hadoop are no different things. Talent is mostly, it's mostly an ETL based tool, and Talent works on top of Hadoop. Talent is a different tool, but it is not that Talent provides any kind of data processing or data storage capability. What you do is, you have data, you have processing capabilities in Hadoop, and you use Talent on top of Hadoop. So these all three technologies that you're talking about, they're very different, and it's like comparing apples to oranges. If you can talk about, if you talk about apples to apples, then my question, I'll rephrase the question for you. Why is Hadoop more popular than other big data solutions like Teradata and Exadata? That's a question that would be more, correct to ask at this point of time. Do not worry, guys. We'll talk about it later on. But if you ask me why, so we talk about big data, right? We know what big data is. Big data is a problem statement. That's what we talked about right now. So why is only Hadoop being quite popular? First thing is, it's open source. Because it is open source, it's free to use, anybody can use it. Second thing is, people are talking about providing business solutions. You cannot just think about Teradata, Exadata, these are different solutions provided by Oracle, but they come with a fortune. You cannot just think about scaling up your clusters or setups, very, very complex systems. And secondly, it costs you a fortune. So nobody wants to pay up that huge amount of money into a vendor locked system. Hadoop is open source. A lot of people use Hadoop. Hadoop is free to use, and you'll have so many things being solved by Hadoop that Teradata doesn't help solving, because Teradata is mostly a database based solution. When you talk about Hadoop, it is not only about data storage that will come across later on, but it's also about data processing. All right. So Misha says, is Hadoop only framework or OS? Neither. Hadoop is basically a platform. You can talk about this as a framework, of course, but Hadoop is mostly it's basically a platform. Inside that platform, we'll have different set of tools, each tool trying to solve one particular business area inside Hadoop. All right, so guys, let's not get confused. One thing is, big data is important. We have understood right now, because No, it doesn't matter, how much money you, spend into buying cluster or buying servers. Your servers will have a limitation with respect to storage and processing, right? Oracle has it. If you're talking about terabytes and petabytes of data, your Oracle might not be having that amount of structure to save the data. Oracle doesn't have it. Oracle's biggest size in one table is around 10 terabytes. You cannot have more than 10 terabytes worth of data in one single table. So with all the technologies in today's world, you are always limited by the storage or the processing capabilities. So you have to think about some solutions. So one such solution is big data solution. Now the question is, in this big data solution, there are so many different vendors, so many different solution providers. Why Hadoop? The answer is Hadoop is free, Hadoop is scalable, Hadoop is robust, and we'll see in these 30 hours what kind of advantage Hadoop provides. With respect to other systems like Teradata, Exadata, which I told you about, these are vendor lock system, only Oracle supports. And those technologies are very much associated with a database layer. So you're not talking about processing, you're only talking about data storage in a particular way. So cost, solution offering, limitations, scalability, futuristic thought process, these all limit all of the big data solutions. But when you talk about Hadoop, it's a growing platform, it's an open source platform, and people are creating more and more tools and services and adding those services as part of this framework of Hadoop. So Hadoop is gaining a lot of popularity because of this. All right, Tulasi says, so far I have worked in BI technologies. Even all BI technologies are used for business decision making and allowable for multiple sources. All right, so good question. So guys, question is, I'm sure a lot of people here are coming from BI. Question is, what does BI do? Informatica is a BI, and you're talking about, Pentaho is a BI. You're talking about a lot of different BI-based systems. What does BI do? BI will not store the data for you. BI cannot process the data for you. Why? Yes, it can, but to a certain extent. If have anybody worked with terabytes of data in Informatica, guys? Not possible, right? Your Informatica Power Center, your Informatica BDE that sits on a single machine, a tool that sits on a single machine will always be restricted with respect to the storage and the processing capabilities, right? So what happens is you use Hadoop as a backend, you use Hadoop as a data processing, data storage layer. You collect all the data from all those different channels. You put the data into Hadoop, you process the data into Hadoop, and the process data, you use the process data and show this process data using your BI tool. So BI is only for visualization. We'll talk about it later. There are different layers in providing a solution with respect to Hadoop. So when we go and talk to a client and provide them a solution, the solution is not only about the storage and the processing layer. It is also about ETL. It's also about BI. BI, what it does is the process data that you store into Hadoop, the BI can use that process data and showcase the process data in a more presentable charts, graphs, and matrices, so that the people, the management who wants to take a decision, they get a more visual representation of the data for making their decisions. Make sense, guys? So honestly, guys, maybe the first hour itself is the first hour of the first class. I know a lot of questions, a lot of answers that I'm giving you. I'm trying my best, but it might not make a lot of sense. But yes, trust me, as we move along, you will understand the differences. And your questions are totally valid, guys. But yes, I think we should move ahead and we'll see how things get clarified more. But do you have any outstanding questions, guys, till now? Anything you think about? First class, very important, guys. I believe that, because in first class we have to learn a lot of things. First class, ask questions, because when you ask questions, you get your confusion cleared. If you only think about the ways we are talking about, then you'll still have a lot of things in the back of your head. So if you have any questions, confusions, ask questions and get it clarified, and then start learning with an open mind. So any question, guys? Welcome. Rajiv says Hadoop is a platform which communicates with all channels. Not really. Let's talk about Hadoop as a data storage and a data processing platform. That's it. Hadoop provides a data storage layer where you can dump the data from all different processes. Now, who dumps the data? Does Hadoop provide some kind of tools to communicate to external world and fetch the data, or the external world guys do have some kind of an API, some kind of a process which can basically dump the data into Hadoop. Is it a push mechanism? Is it a pull mechanism? Let's not go into the details. For now, think about Hadoop as a platform which holds the data. Somebody can dump the data there. Once the data is available in Hadoop, you can process the data and then move along. All right. All right, so Mohammed says, how much minimum amount of data is required for Hadoop to give effective results? Well, there is nothing like that. As I said, Hadoop doesn't try to do certain things for you. Hadoop is not an algorithm that if you feed 1 terabyte of data, it's going to give you better results, and if you feed it 10 terabytes of data, it's going to give you, even better results. No, Hadoop is not algorithm. Hadoop is just a platform. What happens is the same thing that has happened in the past. If I start to make a decision in my business, let's say I owe a business and I want to make a decision. If I feed my system, any system, be it Hadoop, be it non-Hadoop, if I want to make a decision based on only 1 day or 2 days of data, I might be getting a wrong decision. But if at the same time, if I want to make a decision and I invest 10 years worth of data and I basically make a decision, and that decision will be better, right? So this is a universal statement, guys. The more data you have, doesn't have to be Hadoop. The more data you have in any kind of business solution, the better the results will be. Because when your window of reference is bigger, your results are more aligned to what should be in the actual world, right? So the lesser data will eventually lead to wrong decision making. That's a golden truth in any kind of data analytics. What kind of companies are currently using Hadoop? All companies, trust me guys, all companies have switched to Hadoop already. So any company, all the Fortune 500 companies, if you talk about Best Buy, Vodafone, Halliburton, talk about Shell, if you talk about Westside, AT&T, I have worked with all these companies. So I can at least tell you from my experience that these companies have basically moved into Hadoop. That's for true. Umesha says, can it process all kinds of data? Yes, that's the idea. If you dump all kinds of data and you cannot process the data, then what is the good in that, right? So yes, Hadoop is a platform for storing the data and analyzing and processing the data. We'll talk about these things, how to do that later on, but yes, it can do it. Subhash says, what are the different growth opportunities we can see from different components of Hadoop ecosystem? Well, it depends, as I said, it's not a programming language. Hadoop is definitely not a programming language, guys. It's definitely not a programming language. So it's not that you're going to learn something and all of you are going to be oriented in certain ways. No, it doesn't happen like that. It's a platform. And when you talk about a platform, the best part is, you bring your own experience. If somebody is good with Oracle, they understand the data, they understand, data relationships, then they can bring their own experience of identifying the data relationship and work with Hadoop. Somebody is coming from a programming background, they know how to work with different kinds of custom solutions, they can work with the custom-based solutions offering from Hadoop. Somebody has an ETL experience, they know how to massage the data and process the data, then it will be a great experience for them to bring their own ETL experience and work with Hadoop. So net guys, what I'm trying to say is Hadoop is not it's not a programming language that you have to learn. It is an ecosystem. It is a platform. It is it's an umbrella of different tools. Now there are a lot of tools which will do the same thing that you have been doing up. Only difference is now it works with the bigger data with different kinds of data. So that's the only difference. All these days that you have been working, you'll be working the same thing, even after moving to Hadoop. The only difference is now you'll be working with better and complex and more schema-less data. All right, so what are the different growth opportunities? Okay, do you need to use any other tool for report visualization which is generated from Hadoop? Yes and no, Arvind. To be very honest, yeah, see, at the end of the day, who uses your what is the need? So imagine that I have created a wonderful recommendation system. I've created a very wonderful system, and my system, looks into last 10 years worth of somebody's buying and selling patterns and recommend certain things. Now let's make it even simpler. My recommendation engine is based out of the movies that I've seen, and my recommendation engine is going to recommend me a movie that I should see. Very simple. Question is, if I say that these are the list of 50 movies that I want to see, it will not make things more appealing, because at the end of the day, if I have to make a decision, I want to make it more visually appealing, that these are the kind of movies, and this movie I should definitely see, because that's exactly how or what kind of movies I like. This is a movie that I might want to see, but I even can ignore. So at the end of the day, visualization is all about presenting the data. Because I'm sure when you want to create those recommendation engines, or when you want to create those data process outputs, those outputs are to be used by the management team to make a decision. If you go and give them 1,000 rows of black and white tabular data, they will not get that vibe. No management team will look into 1,000 lines of tabular data and make a decision. No. But at the same time, if you want to draw a graph out of this 10,000 lines and represent your data in a reporting format and give it to your management, the management will and have a great platform or have a great aspect of making a decision. So at the end of the day, Hadoop is not for your own use. You're not using Hadoop just because you want to learn Hadoop. You're using Hadoop because you're collecting the data, processing the data, and based on the data you are making a decision, or you are not making a decision, but you are enabling your management team to make a decision. So when you go into your management team, it is recommended to use those BI tools, because that is how you can understand how the data is trending. That is the reason why people use BI. BI is a layer up and above your Hadoop outputs, because you want to create or get a more graphical, visual representation of your hard work that you've done. Subhash says, how about somebody from the testing background? Well, there are a lot of testing opportunities, honestly, Subhash, talking about Hadoop, but honestly, as I said, it's all about a platform, and in a platform, uh, testing does provide a bigger deal, but it's all about data. So yes, mostly I've seen people who coming from Oracle background, coming from programming background, coming from infrastructural background, coming from networking background, coming from security background, coming from data science background. They basically bring their own know-hows into that, and that's how they leverage Hadoop. So maybe along the course, when we discuss and talk about these Hadoop things, something might interest you. Along with testing, you might think about picking up another skill set which will help you in working with Hadoop-based solutions. All right. Mohit says, I'm working with Teradata. All my experience will be useful in Hadoop. Yes, Mohit. Teradata is mostly a big database solution. It is definitely not Hadoop. It is a big database solution for a database system. So instead of you saving all the data into Oracle, what you do is you buy a Teradata, and now the Teradata holds onto your terabytes and terabytes of data. Hadoop is not only the data storage platform. So yes, it will help you, but do not think about Hadoop as a like replacement for Teradata, because Teradata, as I said, it's only for data storage. Hadoop not only does data storage, but it also does data processing. And later we'll also see that Teradata normally talks about tabular schema-based data, right? Whenever you talk about a relational database like Teradata, Oracle, or DB2, you normally talk about a schema bounded to the data. But here we are talking about Hadoop, where we do not bound the data with any schema. Now we are talking about free-flowing data, we are talking about social media data, we are talking about log data. So any data can be handled. So in that way, Hadoop is or Hadoop provides you different flavors with working with data which might not be even available to be stored in a relational world. Make sense? Okay. So with all the discussions that we have, I'm sure that we can very easily define what is big data now. So with all the discussions, all the questions that we answered, let's try to define what is big data. So one thing is important, big data is talking about huge amount of data. So big data is a problem statement. So big data is a term, it's a business problem term. If somebody says I'm working with big data, then you understand that he means to say that he is trying to solve problems which originates from big data. So big data is not a technology. You cannot say I have a I have 10 years experience in big data. It doesn't make a lot of sense, because big data is actually a problem statement. It talks about a problem, the kinds of problem people face. So what kind of problems people face? People face problems with respect to collection of the data, which is complex, difficult to process, and which cannot be handled by traditional systems. So any kind of problems, any kind of problem statements which cannot be handled by traditional systems. Why you cannot handle those kind of problems in traditional systems? Because a lot of things. First thing is the limitation to the data processing and the data storage layers. Second thing is the complexity of the data. Third thing is the structure of the data. Fourth thing is the type of the data. So you get a lot of problem statements in big data world, you talk about a lot of problem statements that has arisen today because of the large amount of the data, the complex structure of the data, the type of the data, the different sources of the data, and different ways of processing the data. So any kind of business problem that talks about capturing the data. How do you capture huge amount of data? How do you curate huge amount of data? How do you store huge amount of data that to a complex structure in a different format? How do you search that huge amount of data in quick time? How do you share the data across multiple uh, applications? How do you transfer the data from one application to another? How do you analyze the data? How do you visualize the data? So any kind of problem statement that talks about one or more of these problem statements is tagged as a big data problem. So any kind of problems which are associated with the curation, capturation, storage, searching, sharing, transferring, analysis, and visualization of huge amount of data can be termed as a big data. And the problem solution that you offer with respect to these kind of problem statement is called a big database solutions. There are different kinds of big database solutions. We, as a part of this course, we're going to learn about Hadoop based big data solutions. Make sense, guys? The difference between Hadoop and big data? Rajiv says we need programming here. Yes, when you talk about platform, the platform will have to process the data. What will you do storing the data? You have to process the data. So when you process the data, what happens is you bring your programming skills. Now the question is, does Hadoop provide you a separate kind of programming language? No. Hadoop provides you the same kind of programming language that you've been using for all these days. So you can use Java, you can use Scala, you can use Ruby on Rails, you can use your Oracle-based skills, you can use your Python-based skills. So any kind of programming language, most of them are supported by Hadoop. So Hadoop doesn't teach you a new programming language from scratch. In this 30-hour course, you are not learning a new programming language. Hadoop doesn't ask you to learn a new programming language. Hadoop is a solution offering and use your existing skills in a more distributed fashion. So what is Hadoop? It's a distributed programming at the end of the day, right? You're solving a problem by dividing the problem across multiple nodes. Same horse-driven cart problem, right? So one horse is not driving the cart, it's the 4 or 10 horses together. Same here, one machine is not processing the data, all the machines together process the data. So your programming language utilizes the distributedness of this programming framework, but use the same programming language to solve the problem. Kanti says, can Hadoop handle search data? Yes, absolutely. If you look into Amazon site, guys, I'm sure you might have seen Amazon site. You search for something in Amazon site. You search for watches. Look into the speed in which you get the response from Amazon site. It cannot be done. Amazon has billions of product catalogs. You cannot go and search a database and get a response back in that lightning fast fashion. So all those e-commerce retail sites, they are definitely using uh, you know uh, search mechanisms of Hadoop. So Hadoop does provide searches. So Elasticsearch, Solar Search, these are all components inside Hadoop. Can't see if I'm going ahead of myself, I'm answering you. Yes, these are part of Hadoop. So guys, net important thing is search is a very important mechanism. When you have petabytes of data, searching for the one record in that petabyte of data would be a huge challenge. Nobody does it. I'll give you another story, guys. I'm sure you might have done it, and I have done this, when I was, quite young. So I'm sure if there is a table, and let's say there is a table in Oracle, and by mistake, a lot of you might have done that. You did a select star from the table. Did you do that, guys? Anybody? Select star from a table which has huge amount of data. You did. I'm sure a lot of people by mistake. Muhammad has been very honest and said yes. And what is the time, guys? What is the time you get a response from, guys? Does it take a lot of time? It definitely takes a lot of time, right? Sometimes it takes 30 minutes to 1 hour to get a response back, right? And normally the PL SQL developer just hangs out. Frustrating experience. I'm sure all of us have had it at least once in their lifetime. It crashed our database once, Kanti says. Absolutely right. It happens, right? So Oracle has limited amount of data. Even in that limited amount of data, a select star will take you ages. Imagine if I have petabytes of data and I want to search one single record in that data. The process is going to take ages to complete. But in today's world, if you talk about any kind of retail commerce site like Amazon or any other site, I'm sure you might have seen that even though they have huge amount of product catalogs, When you search a data, the response is lightning quick. And that's what happens with Hadoop-based solution. Your searches, your data mining, your identifying the data, transferring the data is super fast. Why? Because now one single machine is not solving your problem. It is a distributed process. Your one single request has been handled by multiple nodes together. Divide and conquer. Make sense, guys? So what is big data? Of course, we have identified that. What is an use case of big data? Well, apart from the ATM example that we have talked about, one such example will be the New York Stock Exchange. They handle terabytes and terabytes of data per day, and the trade stocks basically fluctuate very, very frequently, right? Every minute there's this stock, values will trade and up and down. So in order to ensure that you're getting the most recent real-time data, visualization of the stock trends, you normally use Hadoop. So New York Stock Exchange, they use Hadoop for forecasting and identifying and maintaining and managing this huge amount of data. Just an example. All right. Okay, guys. So what we'll do is, maybe we'll take a quick 10 minutes break right now, and then when we come back, we're going to continue from where we left off. We have introduced ourselves to big data. We have introduced ourselves to why is big data important, what is big data, a couple of use cases of big data, and seen what kind of problems big data solve for us, right? So at least we have got our bases covered. Now, if somebody comes and talks to you about big data, at least you can go and tell them that no, big data is not meant for solving a lot of business problems. Big data is focused on solving batch mode data decision based problems. Big data is not used for solving a web problem, maybe it is used for making a business decision. So at least this much is clear for us right now, right, guys? Make sense so far? Yep. All right. Okay. So with this amount of introduction to big data, guys, when we come back, we're going to talk about what is big data, what are the different components of big data, and slowly get introduced to a Hadoop-based world. So that's what is planned for us in the next half of this program, guys. So let's do one thing. Let's break for 10 minutes. When we come back, we will continue from where we left off. All right. Hi, guys. Are we back? Shall we start? All right. So okay. So we got a text from Vasu saying, my name is Vasu, sorry I'm late, I just joined. Alright Vasu, nothing much that we have talked about technically, we're just talking about a few stories and identifying what is big data. So do not worry, I'll request you to go through the video recordings, which will be available in after this class. And whatever you have missed, nothing much, and we're going to talk about them all through these, sessions and all. So nothing that you have missed, there's going to be a challenge, nothing. All right, and most of the time we are actually talking about a few questions that we had and interacting with the people and experience, sharing experiences and all. So nothing much. All right, guys. Are we back, guys? Shall we start? Okay. So this chart gives us a representation of how and what kind of changes have happened over the last 10 years. So if you look into this chart, it tells you that that there are two components, of course. There are two components when you talk about data used for making a decision. There are two components. First thing is the structured data. Where do you get the structured data? The structured data are available in the traditional transactional databases available in every company. So if the company has a database, the company's database will have the customer's data, and those data will be mostly structured, oriented towards a particular use case. So every company will have their own structured data, and if you look into the last 10 years, the structured data has actually grown pretty linearly. It was a quite good consistent growth of data over the last 10 years. However, we have talked about this, last 1 hour we have talked about how to make a decision, what you need to make a decision. Your decision making ability cannot only be restricted by these 10% of the data. Your decision making ability has to be also associated with the remaining 90% of the data which is not available in your organization, which is available outside your organization in different formats. So when people have identified that what kind of data is available and how the data has to be absorbed for making a decision, they have found out that there is an exponential growth of the unstructured data over the last 10 years. So can anybody tell me, guys, what has happened in last 10 years that you see unprecedented exponential growth of the unstructured data? Mohammed says social media. Absolutely right. So social media, emails, e-retailing, everything. Umesha says IoT. Well, IoT is still catching up. So IoT to contribute to this has a long way to go. But yeah, mobile devices, yeah, I can agree with that. So net, yes, social media has played a big role. Now, when you buy something, when you launch something, when you want to inquire about something, everything is available. All the information is available on the net. So your decision-making power cannot rely only on the 10% of the data which is available in your system. It has to be basically clubbed along with the 90% of the social media data which is available free of cost over the internet. And only when you get 100% of the data together, and then when you analyze your 100% of the data together, you get a decision which are better in, which has a better chance of being correct. So if your decision is based on 10% of the data, chances are your decisions are 10% correct. But if your decisions are based out of 100% of the data that ever can be collected, then obviously your decisions will be 100% correct. So in that regard, guys, important thing to understand is, you need a platform. There is a requirement of a platform that can handle not only the structured data, but also the unstructured data. A platform which can equally be adversed with the entire 100% of the data, not only the 10% or not only the 90% of the data. In that way, we have seen that because of the exploding nature, because of the exponential growth of this unstructured data, we have reached a situation where no longer we are limited, no longer we are happy with making a decision only on the 10% of the data which is available to us, and most importantly, because the data has grown so much in exponential fashion, that no matter what you do, no matter what kind of solutions you provide, no one single server can handle that amount of data. So you need a solution which can handle and process that amount of data, and that is the only reason why continuously from 2005 to 2015 we have seen that there is a requirement of a platform like Hadoop. So Hadoop was not a question that people asked on 2005 because the data was so limited, and the problem remains the same. At 2005 also you wanted to make a decision in your business. At 2015 also you are making the same decision in your business. The only difference is the data. Hadoop is not doing something new, guys. Hadoop is not trying to solve a problem that has never been solved before. Hadoop tries to answer the same question that you have asked Hadoop, or that you have asked your technical consultant 10 years back. The only difference is now it can handle, process, and manage that huge amount of data. Sandeep says Hadoop can handle both structured and as well as unstructured data. Absolutely, yes. All right. Okay. Now the important question for all of us, that all right, we understand what is Hadoop. We are going to become data scientists. We are going to become data analysts. We are getting a feel of what Hadoop is, what does the Hadoop platform do. Now imagine that you go to your client place. You go to a client, you talk to the client, and you start interacting with the client. Now, is it possible that anything the client says, you just say, no, you need a Hadoop-based solution? Do you think every single kind of problems can be tagged with a Hadoop-based solution? Not really, right? So if you are a technical architect, if you are a solution architect, then if you are trying to suggest Hadoop as a technology to your clients, you have to identify what kind of use cases categorize as a Hadoop-based solution, right? So IBM has defined four vertices, four V's of identifying what can be categorized as a Hadoop-based solution. So we have four different V's, four different vertices that categorize or tags a particular use case, whether it can be a Hadoop-based problem or not. The first thing is volume of the data. So if your client says that I have huge amount of data and the data is so huge that it cannot be handled by a single server, then you're pretty sure that this kind of a problem is associated with Hadoop Big Data solutions. Do you agree, guys? Yes. So volume can definitely be one of those criteria that can ensure that whether you use Hadoop as you use Hadoop as a solution offering to your client or not. Yeah. Yes, guys. Okay. Second thing is, I'm sure, a lot of people have been talking about, experience with Java and .NET. Tell me one thing, guys, so what happens is, in your system, you design a system, and that system is not an isolated system, right? Any system you design, that system will be an open source system interacting with external world. So when your system interacts with this external world, there is a rate in which the data gets absorbed by your system. So normally in Java or in .NET, we talk about building web services. The web services are, channels of identifying how external systems will be putting their data into our system. So normally people talk about those uh, kind of framework. API, it can be APIs, web services. So guys, can you tell me, if I build a web service with a .NET or a Java framework, how much of events can I handle? I can handle, to be very honest, with my own experience, I can tell you that normally any kind of web service can handle 500, 600, maybe 1,000 events per second, and that to on an, quite, huge extreme. None of the system can handle more than maybe 1,000 events per second. But when you're talking about a big data solution, I'll talk about sensors, some weather forecasting sensors, some mobile application sensors, some GPS sensors. They'll be continuously sending millions of events per second. How do you design a system? How do you create a system that is, sending you huge velocity of data? The data that is being input to your system are in such a velocity that none of your traditional systems will work. Then what kind of solutions you suggest to your clients? When you suggest a Hadoop-based solution, when not only a volume can be a problem, but velocity of the data can also be a problem. When you are thinking about interacting with the external world, and the external world is sending you terabytes or millions of events per second, which cannot be normally handled by your traditional systems, then you think about a Hadoop-based solution. So volume was one such vertex, velocity is second vertex. The third one is variety. We have talked about variety. When you talk about the ATM problem, maybe we have seen that data, in order to make a decision, the data is, saved into different kinds of channels of data or channels of sources. You'll have some free flowing text, you'll have some audio data, you'll have some video data, you'll have some relational data, you'll have some image data, you'll have some, social media tweets. So the variety of the data, the sources of data are varied, and when the sources of data are varied, the data that you collect will be having different variety. But when you start processing the data, or when you have to make a decision on the data has to be moved into a common format. So whenever the client talks to you, is saying that I have different sources of data and all the sources are different, then you can propose a Hadoop-based solution to them. So volume, velocity, variety are the three most important vertices. These vertices define whether you need to go with a Hadoop-based solution or not. Apart from that, there is another vertex that talks about the value of the data, the veracity of the data. The veracity of the data says, a lot of time it happens that your company, your business is small right now. Your company is okay with using, a relational, traditional data, database system as a backend. But if you think about futuristically, if you think about from the future, what you normally do in Oracle system, guys, in Oracle system, you normally purge or archive 3 years worth of data. Your Oracle system cannot handle huge amount of data. So every 3 years, what you do is, or maybe one every year, what you do is you purge the data and lock them up away in a tape. Hadoop says, do not lock away your data. Do not throw away your data. Your data is the most important asset in your company. So if you have data, do not lock it away. What you do is you build a small Hadoop cluster. You create a Hadoop cluster, and that Hadoop cluster can be used for only dumping or archive data. You just archive all the data into your Hadoop cluster. The cost of ownership of a Hadoop cluster will be very small, because at the end of the day, you are building it out with commodity hardwares. So you will not be spending a lot of money into managing and monitoring and maintaining a Hadoop cluster. So what you do is, instead of you locking away the data, you store the data into Hadoop, because you never know what kind of value we can gain out of the data. So value of the data, expressing the value of the data, identifying the value of the data, and trusting the system, trusting a Hadoop system that you can do a lot of analytics later on with that data, provides you a third definition. So a lot of time your company, your client will say, no, I'm okay with Oracle. My Oracle systems are working fine. I'm sure, my Oracle systems will work fine for next couple of years also. I do not see why I need to change to a new technology. Then you can tell him or tell the client that veracity plays a very important part. Today, you do not need Hadoop, fine, you do not use Hadoop. But you create a Hadoop cluster, you make the Hadoop cluster up and running, because you should not be locking away your data. One example, guys, would be WhatsApp. So, guys, Facebook bought WhatsApp for around $400 million. Can anybody tell me why? For a company like Facebook, anybody, a product team could have developed a product like WhatsApp in a week. I can tell you that much. Why do you think Facebook bought WhatsApp for a huge amount of money? What was the reason? Yusuf says because of the data and the customers. Absolutely right. In today's world, whoever has the data has the customers, and whoever has the customer have the business. So in today's world, locking away the data, throwing away the data, or permanently purging the data is never ever a solution. If you have the data, you can use the data for making a lot of analytics, a lot of predictions, and a lot of business opportunities for you. And that is the reason the fourth V or the fourth vertex of a Hadoop solution is to value the data, to trust the data, and to ensure that you can store the data in the Hadoop platform and analyze the data later on instead of blocking away the data. So these are the four major reasons why, when, and why, when, and how customers or clients should be using Hadoop. Any question, guys, till now? Okay. So maybe it's it's a good time to talk about another story, guys. Do you think we should explain another story? Talking about all those four vertices together. Why is Hadoop important for us? Okay. So imagine that I'm going to tell you a story about how things are happening in Hadoop world. How Hadoop is playing an important role in our day-to-day life. Imagine that, guys. I just want to buy a internet service. I want to have an internet service at my home. So what I do is I go and search the market and see who gives me a better proposition, who gives me a better offer on my internet plan. So I go to one of those internet providers and they tell me that, okay, what you do is for $1,000 I'm going to give you 10 gigabytes worth of data usage. And maybe I'm quite happy with that. I'm sure that this is the best deal that I can get. So I start up a I bring the application form, and some days later I have a working great internet in my home, and I'm pretty happy with that. I start using the internet. Maybe after a couple of months, what I do is I download Skype. So after a couple of months, I download Skype. As soon as I download Skype, I get a call from the customer care, of my internet provider and say, sir, you have downloaded Skype, and we have a great offer for you. We are going to give you 15 GB worth of data usage only for $200 extra. So they're giving me an offer saying that we're going to increase your data usage by 50%. You have to only pay $200 more. And for me, it's a win-win situation. Why? Because I know that I've downloaded Skype. I know that I'll be using a lot of data, and my internet provider, they're giving me a solution. They're giving me an offer before I go and search for it. And secondly, it's a win-win situation even for the entire internet provider, because now I was $1,000 worth of customer. Now I have become a $1,200 worth of customer. So it is a win-win situation for everybody when you use analytics, when you identify what things are happening behind the scenes, and you go to your customers before the customer comes to us. In today's world, guys, trust me in this. It's all about customer-centric approach of business. You cannot just hold on and think, okay, I have a customer base, I cannot do anything, I cannot increase the business plan. Knowing your business is something considered to be naive in today's world. Everybody knows their business. You cannot differentiate yourself from your competitor only by knowing how well you can do your business. In today's world, it's equally important, and it's even more important that you know your customers well. Knowing your business is something that everybody expects you to do. Knowing your customers differentiate how good or how bad company, or how good or how bad a solution provider are you. In today's world, Apple is one of the most precious brand, guys. Why? Because they know what their customers want, and they have a loyal customer base. If you have a loyal customer base, that's exactly what you wanted in your business objective. In order to keep your customers loyal to you, you have to offer them something even before they can come down to you and ask for something. And that's the direction in which the entire business is moving today. And because of this, Hadoop plays an important role, because when you're talking about having millions and millions of customers working and using your product for 365 days a year, 24/7, you have to analyze the business, you have to identify how the customers are using your products and suggest them better and offer them a better platform. And that's exactly what Hadoop does for you. Make sense? All right. So during our journey, guys, into this 30 hour, we'll see a lot of Annie. Annie is pretty angry all the time, and she is always with questions. So let's see if you can answer a couple of questions from her. So this is a very important question, guys. Think about it and answer. The question is, categorize those sources of data as structured, unstructured, or semi-structured. Can anybody tell me what kind of data would you tag XML files as? Will XML files be structured, unstructured, or semi-structured data? Muhammad says structured. Okay, Hari says semi-structured data. So both of them are correct. Honestly speaking, it is a semi-structured data. Why? The reason why we classify something as a semi-structured data is because a structured data is something that we do not have to parse or do not have to have any kind of custom parsing required. Somebody gives you an XML file, you cannot just get the data out of the XML file until you know what kind of relationships these XML tags have. So XML data are mostly categorized as semi-structured data because you need to write a parser to parse the content in that particular fashion from the data. All right. XML file, semi-structured. What about Word document, guys? Word document, Vijay says unstructured. All right. Word documents are totally unstructured. We all know that. Email body. What about email body, guys? Email body unstructured. Okay. Vinay, Arvind, Naveen, everybody is saying it's unstructured data. Absolutely right. What about ERP systems, database systems? Structured, Naveen, Kranti, everybody is saying it's structured data. Absolutely right. Structured data. All right. Okay. One last question from my side. What about an email? An entire email, what kind of classification will classify it to? Entire email, guys? Vasu says semi-structured, Muhammad says unstructured. Think about it, guys. So normally an email, entire email is structured data because the email will have a particular format. Normally if you're talking about a SOAP message, it has a format. If you're talking about an iMessage, it has a format. Every single email has have a format, and that format is well defined. Everybody knows the format. It'll have a header, it'll have a body, it'll have attachment, it'll have a footer. That's it. So important thing is not about whether we are correct or wrong. Important thing is to understand that yes, when you go about providing a solution to the clients, the first thing we all have to do, whenever we provide a solution offering with respect to Hadoop, guys, trust me, this is the first step we do. We try to identify different channels of data, and based on different channels of data, we try to classify the channels of data as structured, unstructured, or semi-structured. Why? We later see that the choice of whether the data is structured or semi-structured or unstructured, depending on that choice, we select a tool from Hadoop to identify what kind of tool can process the structured data, what kind of tool can process semi-structured data, and what kind of tool can process unstructured data. So the first thing ever you need to do when you get a end-to-end business solution to offer to your clients is to identify the channels of sources and classify those channels as structured, unstructured, or semi-structured. So we did good, we have classified the data, and that's what exactly you need to do later on. All right. So any question, guys, till now? So what we'll do is, for a couple of next slides, we are going to talk about certain use cases. I'm sure a lot of use cases, talking about the use cases will help us identify what kind of business solutions Hadoop provide and what kind of solutions people are using Hadoop for. Okay. So this is something that we're going to talk about right now. But before that, guys, any question till now? Any feedback till now, guys? Questions, discussions that you want to have? Anything? No? All right. Okay. So first thing is, what kind of businesses use Hadoop? Hari says, do you have access to this PPT? Yes, you have access to the PPT, and this PPT is available in LMS. Uh, Prashant says, does Hadoop have any competitor? Yes, there are lots of competitor. Big data solution, there are a lot of different vendors providing big data solutions. One of the big data solution is Hadoop. Similarly, you have other big data solutions like Teradata, Exadata, and all those that we have talked about. All right, so there are competitions. There will be competitions, but as we have discussed, Hadoop provides and still is a forerunner in providing big database solutions, and the reasons is something that we have discussed, and the reasons are something that we're going to talk about all throughout the next 30 hours. All right, so yes, now Hadoop has a lot of competitors like Exadata, Teradata, a lot of other things. All right, web and e-retailing. So one of the ventures, one of the avenues where we can see a lot of Hadoop-based solution offering are web and e-retailing. I'll give you an example. Okay, so imagine that Prashant has gone into a website and has bought a Rolex watch. And Hari has also bought a Rolex watch. So this is Prashant, this is Hari, and Hari has also bought a Rolex watch. And Prashant has bought a MacBook, and Hari has also bought a MacBook. And Hari has also bought a iPhone. All right. So in earlier days, what used to happen was, if Prashant buys a Rolex and a MacBook, if he opens the website again, his website will be recommended to buy maybe a Casio watch, maybe a Tissot watch, maybe something else, Citizen watch. Idea was the recommendations were based out of databases of like-minded products. Similarly, if somebody has bought a MacBook, he would have been suggested to buy a Lenovo product or maybe an HP product. In today's world, we know that if Prashant has bought a Rolex, high chances are for next 6 months or to 1 year, he'll not buy another watch. Showing him examples of or recommendations of watch is not going to do any good. Do you agree with me, guys? That is how, in earlier days, we used to have websites designed altogether database based solutions. If somebody buys a Rolex, he'll be showing all different kinds of watches for him to buy. Nobody buys after buying a Rolex, nobody will buy another watch for next 6 months. That's a logical conclusion. So what happens is, in today's world, what to do is, we try to find a person who is having the interest in those items which has Prashant's interest also. So chances are Hari's interest level matches Prashant's interest level quite a much. You have Rolex and MacBook, all of them are buying in the same pattern. So what you do is, you recommend Prashant to buy an iPhone, because chances are, if the choice of Hari and Prashant are same, then choice of buying an iPhone will be hugely matched. And that is we talk about as recommendation engines. So a lot of companies have built recommendation engines. Personally, I've worked with Best Buy for their own recommendation engine. And that's how we have changed a database-driven recommendation engine with a Hadoop-based recommendation engine. The point is, Prashant has used this website for 1 year. Hari has used this website for 1.5 years. And similarly, I'll be having billions of customers. Do you think it is possible to compare users along with their, along with how well they are tied together in a relational database? In relational database, you do not have the luxury of saving that huge amount of data and searching that relationship in that huge pile of data. In today's world, it is important that you store those last 1 year's worth of data and whatever time of data you have, and then try to find out the matches, identifying what kind of profiles are quite tagged together. And for those kind of business offering, solution offering, you need Hadoop-based solutions. All right. Second example in web retailing would be ad targeting. I'm sure you might have opened up. So guys, I'm sure you might have gone into a web browser and searched for a lot of things. You might have searched for maybe, let's say, you search for a mobile phone. If you search for a mobile phone, and then later on, if you go inside a Facebook web page, you log into a Facebook. Have you seen, guys, that right side of a Facebook will now be showing you a lot of different offers on the phone that you need to buy? Have you got that experience, guys? If you have searched for something in your browser and then you log into your Facebook, the ads being shown to you will be quite targeted towards the kind of search you have done in your browser. Hari says yes. So same thing, ad targeting. So everybody is keeping a track. Imagine that you are not the only one. You will have billions of people logged into the system or logging into Facebook at the same time. So Facebook uses your own search quality. It searches the ads that you have been searching and shows you a lot of things that you have a high probability of seeing out. And that's what normally we do with all those big database solutions. Third one would be a search quality. Imagine that I'll give you another example. Let's say we have two persons here. We have Vijay and Ashish. Vijay is an avid traveler. Loves to travel a lot. And Ashish is politically inclined. He loves politics, and he loves to discuss about politics. So if Vijay goes to Google and searches for India, he will be given top 10 pages would be mostly about places to visit India, maybe Taj Mahal and Red Fort and all those stuff. But if Ashish goes and searches for India in his search box, then the first 10 top results will be mostly focused around the political scenarios of India. Have you seen that feeling, guys? Two persons giving the same search criteria have different search results, even in Google. Does it happen? Normally we use a term called search bubble. The search bubble not only talks about a universal search result, it talks about the kind of experience you have with browsing the web, and the kind of interest level you have shown into different kinds of web pages that you have visited, right? So based on that, in today's world, the search quality has a huge figure to play based on the kind of your historical search patterns, and that's what we talk about from web and e-retailing. Same with click abuse and fraud detection. So in today's world, online ads, ad targeting, are a huge play. Uh, Online ads are the biggest source of revenues for all the companies, and trust me guys, this is the biggest industry in this world right now. The amount of revenues that Google earns, the Facebook that Facebook earns over the advertisement is more than anything ever has sold for them. So for them, it is very important to identify whether people are using the searches, the clicks, and the advertisements judiciously or not. You cannot just create a, let's say, a lot of people do that, right? A lot of people will I'll give you an example, guys. A lot of people will build their own mobile applications, and they'll when they associate those mobile applications with ads, and then they'll write some bots. They'll write some codes which will go and change the IPs and click on the ads very frequently, and they'll earn a lot of money from that. So there are a lot of ways of identifying potential frauds, click abuses, and fraud detections on online advertisements, and that's a huge industry. So net important thing, guys, is Hadoop plays a big role in web and e-retailing. A lot of use cases have sufficed. A lot of use cases have surfaced when we talk about the kind of solutions that Hadoop provides in web and e-retailing spheres. And these four are the top. Same, when you talk about telecommunications and Hadoop goes hand in hand, because when you talk about telecommunications, you talk about all those variety of data. You talk about SMS, which is plain text. You talk about MMS, which is video data. You talk about call rates, which is audio data. You talk about mobile internet that people uses. So when you talk about telecommunications, you talk about proper end-to-end use case of Hadoop, because you're talking about variety of data here. So a lot of use cases that people have solved using Hadoop Big Data will be customer churn prevention, a lot of network performance optimization, what kind of networks, or which tower should be the best possible tower for you, what kind of network call rates, how the calls have to be channelized, analytics of predictions of network failures. All these are examples of telecommunications. I can give you an example, guys, that one of the projects that I worked with, not for telecommunications, of course. I'll give you an example. So there was one, production plant, and what happens is they had a big plant, and the plant had almost like there were three fields. There were three separate fields, or three separate production plants, and those fields are quite far off from one another. And each of these plants were having 100 to 150 machines. In each of the machines were writing some logs. The problem was, the amount of engineers used to support the three plants were limited. And if one of those engineers has to go to plant one, then there will be less number of engineers who has to go to plant two. So the point was, there are so many different engineers, limited amount of engineers, and three plants. Each of the plant has huge amount of machinery. So our responsibility was to design a real-time dashboard where we used to collect logs from each and every machine. So if there are three fields and there were 100, 200 machines from every field, then is to collect log from around 600, 700 machines. And we used to do a log processing. We had to find and search for the log patterns and see whether some of the logs are complaining about warning messages. And then we used to have a dashboard. The dashboard was divided into green, amber, and red. So, the green ones make sure that all the machines are working properly. And the amber means there is something that is not working correctly, and then red is something that has already failed. So now, with all those kind of 600 different machines and log processing, it was not possible to solve or collect logs and analyze the logs using any other platform or any other solution offering. So what we did was we introduced Hadoop, and Hadoop was basically collecting logs from 600 different channels, and we were analyzing the logs. Logs are normally text files, right? These are free-flowing text. We used to analyze the log files and categorize 600 machines into amber, green, and red. Now, anytime a machine goes from green to amber, we used to notify the engineers. Now the engineers doesn't have to go and search for failures all through the plants. Now what they have to do is to sit on the control room, look into the logs, and look into the live dashboard. Whenever there is a machine that is going from green to amber, they know that okay, it is time for them to go into that particular plant and look into that particular machine, and it has saved the cost of that company a lot. And that is one of those examples where Hadoop plays a very important role in analyzing and making a decision for you. All right. Same with government, in India, there is something called Aadhaar card. You have your retina scan, your fingerprints, your photos, and a lot of things that has been captured into a database. Do you think, guys, it is possible for anybody or any other technology who can create a database that can store your retinal scan, that can store your fingerprint scan, your photos, and a lot of things in a country that has 150 crore of people? Do you think it is possible, guys, to have that volume of data stored into one database? Can you imagine a database doing that? Obviously no, right? So there is no database available. So even for a lot of government-based companies, a lot of government-based projects, we have used a lot of NoSQL-based database, which is a part of big data family. So big data is not only used for certain online or data analytics. It's also used purely as a data storage platform where the data is huge. The volume problem can be huge. The other examples can be healthcare and life sciences. A lot of healthcare and life sciences are moving into Hadoop big data world now. I can give you a very small example from my experience, guys. There was one of these companies for Switzerland, and they were actually, what they did was, they used to get the DNA sequence of newborn child. And they used to send those, DNA sequence of newborn childs to us. So what happens is, the DNA sequence is a pattern. If you put them in a matrix form, the matrix are always going to be symmetry matrix. So the question was, looking into the DNA pattern, it was a 512 by 512 matrix. Looking into the DNA pattern, we have to find out whether there is a genetic issue with this kind of a gene sequence. And the reason was, if a newborn baby has a gene problem, genetic problem, then if the cure or if the curation starts at a very early age, a lot of them can be solved. So they wanted to find out whether this is a perfect match of genetic sequence. If yes, then good. If not, then they can at least go and start a process of curating that. Now, biggest challenge was, a big matrix like 512 by 512. It even takes supercomputers hours to process the data for one single matrix. So what we did was we converted that problem into a big data problem. How? So so every problem has a mathematical representation. The representation is very simple. If you multiply a matrix, a symmetry matrix A, with the transpose of the matrix A transpose, then you should get an identity matrix. That's a mathematical formula. But a lot of computers, they cannot multiply a 512 matrix by a 512 matrix. It's too huge a data to be processed in a single machine. But in Hadoop world, we normally use a 70 node cluster. The 70 node cluster could have done this in less than 3 minutes. In less than 3 minutes, I can multiply a 512 matrix by a 512 matrix, and if I get an identity matrix, I know that this data is a symmetric data. This is a correct genetic sequence. Else, it would be something that is not correct, and we can basically report it back. So these are a couple of examples. These are a couple of real life examples, guys, where people have been using Hadoop to solve business problems and make a decision in critical spheres of life, be it healthcare, be it fraud detection, be it web retailing, be it government-based solutions. Everything we talk about, Hadoop has a chance to play, because we are not trying to provide a new use case that has never been solved before. We are not identifying use cases that has never been attempted. What we are doing is we're trying to identify the same use case that we've been solving for all those years. The only difference now is, because of the exponential growth of data, those use cases are limited with the data sphere. Now we are having an opportunity where we can use that volume of data and make a decision in our system. And that's what big data provides us. Make sense? Same with bank and financial service. I guess bank and financial service is the most common examples of Hadoop-based world. When you talk about fraud detection, trade surveillance, credit card scoring, everything talks about ensuring that your systems are up and running. I'll give you an example. What happens is, I'm sure you might have had this experience, guys, that imagine that you are doing a transaction all your life for last 5 years. You have never used a credit card, anything apart from movies and anything else. Suddenly you go to a shop and you buy a laptop from your credit card. Immediately you'll be getting a call from one of those customer care executives saying, sir, we have seen that there is a anomalous transaction in your card for a laptop. Do you authorize it? I'm sure you might have had an experience like this, guys. Did anybody of you have an experience buying something that you have never bought in a credit card? Suddenly you buy it and then you'll get a call. This is all about real-time fraud detection, right? So whenever you do something that has never been done in your profile, this will be an anomaly. And when you raise an anomaly, there'll be somebody addressing that. Now, how to address this is a different way. Somebody will call you to address this, somebody will block your card to address this. But the point is same, that yes, in today's world, your current transaction holds a huge value, but when you combine your current transaction with your last 5 years worth of historical transaction, you get a pattern. And when you get a pattern, you can identify the pattern and see whether you're doing something that you've been continuously doing, or this is one of those situations where there is a probabilistic cause of fraud. Right? So these are the ways in which banks, as I said, do not throw away your data. Last 5 years worth of data can be used for identifying a pattern, and that's what people do. Same with retail. When you talk about retail, retail has a huge thing to do. I'll tell you an example that happens very frequently in today's world. One of the use cases that I work with. Somebody, goes and let's say publishes a new product. Somebody has, launched a new TV, let's say. Some company has launched a new TV. Now what happens is, you want to find out on a real-time basis whether your business is doing good for that particular product. So one way of doing that is continuously going and monitoring the Twitter. So what you do is you create a Hadoop-based solution which will automatically go and fetch tweets which is hashtagged with that particular product name, and you download all those tweets. I'm sure you'll be getting thousands to millions of tweets per second or per minute for that product. Now what you can do is when you get thousands and millions of tweets per minute, you can categorize those tweets. You can do a sentiment analytics on the free flowing text. Somebody says, I do not like that. So you are using not as a verb and not as an adjective and like as a verb. Then using sentiment analytics, there are algorithms for that. You can tag that particular tweet as a positive tweet or a negative tweet. Now, if you analyze millions of tweets per second or per minute, and you dump the data in somewhere saying that okay, collectively this minute there are 500, there are 50,000 positive tweets and 10,000 negative tweets, that you know that your product that you have launched is doing good in a particular geography. So a lot of people use trend analytics, sentiment analytics to identify what their customers want, how good or how badly the customers are accepting the new products, and how well these these kind of uh, products are being sold in the market. So you can do that, and retailers are doing that actually. They're looking into the social media and finding out your imprints on that product. So net guys, important thing, all these are use cases which are actually being already executed in Hadoop world for all those bigger companies. You talk about JP Morgan, you talk about Sears, you talk about all those companies, people have already implemented Hadoop, and these are the use cases where people have seen Hadoop being implemented and they've been implemented successfully. So Hadoop is a success story. Hadoop is not a very new topic that people are still apprehensive about. Hadoop is pretty mature now. There are use cases in production that a lot of companies have been running out, and Hadoop is here to stay. And most importantly, Hadoop has proved itself that it can solve problems which has never been solved because of this all the limitations, and it has also proved that Hadoop can provide you with the kind of solution that you're looking for in today's world where data and customer focused, customer centric business is an important thing today. So we talked about all those Terra data and all. So yes, one of the success story was Sears is actually a US based retail market, retail shop, and they are very famous for their assertiveness to new technology. Whenever there is a new technology, they are pretty okay with adapting to new technologies. So Sears used to use Teradata and Oracle Exadata, and they used to run into millions worth of infrastructure and management cost. Now that they have moved into Hadoop, they have seen significant amount of drop in their entire investment with respect to Hadoop. So when somebody, we talked about this a couple of times, guys, that are there competitors? Yes, there are competitors, but people have seen that moving into Hadoop provides them with such a big flexibility because you're not buying systems, you're not getting yourself vendor locked, and at the end of the day, you are basically saving money in infrastructure and in solution offering. So these are actual use cases. These are actual success stories that a lot of companies have worked with. All right. So before we go and understand what are the different layers of solution that Hadoop provides, and when you talk about a Hadoop-based solution providing, what kind of solution? What are the different layers of solution that we provide? So before going into that, guys, any question that you have, anything that you want to talk about, discuss about, guys, any question that you have in your mind, any feedback that you want to give me right now? Vasu says hi. Yes, Vasu, please go ahead. Yeah. You want to key in your question or you want me to unmute you, anything is fine. Vasu said, are you going to talk about the approach to implement Hadoop? Yes. We're going to talk about them. So this is the first class. First class, second class, mostly theoretical, understanding what is Hadoop. A lot of you do not have it, that experience working with Hadoop. So we're going to introduce Hadoop, and most importantly, guys, implementation is not a huge challenge, because as I said, Hadoop is not a programming language. Implementing would be something that you have been doing all your life. Hadoop is a platform. Identifying why you should use Hadoop, how you should use Hadoop, and what are the different factors we build in to provide a solution of Hadoop is important. So if you think that, okay, we're going to learn a couple of programming commands and we learn Hadoop, that is not how and what Hadoop is built for, okay? So Hadoop is all about a platform, and learning a platform means identifying the underlying platform, underlying architecture, underlying implementation, and think about what are the use cases we're going to support with that. Vasu says, are you going to think about iterative process or Big Bang? So there is no iterative process or Big Bang in Hadoop. Hadoop is a framework. It's not a waterfall model that you design, code, and implement and test. It doesn't happen like that. If you're thinking about it like that, guys, then it's the wrong way of thinking. You have to unlearn a lot of things, because Hadoop is a platform. When you talk about a platform, then people will say, okay, I have 5 different sources of data. And I think that every day I have 1 terabyte of data being ingested into my system. How do I design a platform? So you have to think about not only from the implementation but also from the infrastructure. You say, okay, maybe I can get you a cloud-based platform. In a cloud-based platform, we'll start with maybe 20 nodes, and you do all your calculations and show why 20 nodes is important for this kind of setup. And then you have to bring all those nodes, you have to create a cluster, you have to set up this process, and you have a underlying infrastructure ready. Once you have the infrastructure ready, then you identify different channels and start ingesting the data. So that is the second step. Once you ingest the data, then you have to do a lot of ETL on the data. So you think about whether I should go with the COTS product, like Informatica or Pentaho, or do I build a custom solution? These are the things, these are the questions as a solution architect you have to answer. And then when you do an ETL on the data, then you have to think whether do I do a pre-processing of the data, or what kind of analytics I do on the data. And those times you have to rely on your data science team, where your data science team will tell you how to utilize that data and do explorative analytics on the data, and reach a particular model. Once you do that, then you have to basically go and talk to your BI team and say, okay, I have a data ready for me. How do you use the data and create all those visualizations and graphs that my management will help understand. So as I said, guys, Hadoop is not a one-shot program saying that, okay, I'm going to sit and code the solution today. No, you require network administrators, you need network programmers, you need an infrastructure management team, you need OS level team, you need data scientists, data analysts, BI teams, and all those people. So collectively, you build a platform, an end-to-end solution offering. And in this 30-hour course, guys, we're going to talk about what kind of platform we're going to build and how we envisage a business solution and try to solve a business problem from the client. All right. It's not a programming language. It is not that we're going to learn a new technology, and we're going to be masters in that now. Okay. All right. So as I said, whatever exactly I told you is exactly what is mentioned in this slide. Uh, Limitations of existing data analytics architecture. So in today's world, if somebody comes to you and says, I need to build a solution, and I have a huge amount of data, I want to process the data, and you do not know Hadoop, then how do you provide a solution? So of course, the first thing is identify different instrumentation of data collection from different sources. You identify, okay, I have a data from Twitter, I have a data from social media, I have data from log, I have a data from RDBMS and a lot of things. So you try to find out and build a lot of products, and you collect the data and store the data. So first question that ever comes to your mind is, what is the platform available that can store all these kinds of data? RDBMS cannot do that, and your normal NFS cannot do that. Your normal cloud storage cannot do that. So I think the first question when you try to solve a business problem in this kind of a world is, what kind of a platform provides you with an underlying platform which can store this all different types of data? Okay, even imagining that you can store the data in different in a particular format. Second thing is, How do you have the data available for data processing? Who can process the data for you? That too, that huge amount of data. That too in a particular time bound, because everything is oriented by SLA. If I have 2 terabytes of data and I want to build a recommendation engine, and my recommendation engine takes me 1 month to run, what is the advantage I'll get? Because by that 1 month, my data has changed, my customer's behavior has changed. So my response to a particular data solution has to be quick. So who can do that processing for me? That's the second question. Third question is, when I talk about normal, traditional solutions will always have a limitation to the size of the data. So my data has to die a premature death. I cannot store the data in my system forever. I have to purge the data. Be it Oracle, be it any other RDBMS system, guys, you cannot store worth of huge amount of data. Your database will become so slow that nobody can use that database. So for us, it's important that we have to ensure that my data is less, but it cannot die a premature death, because if my data is lost, my pattern for users or customer behavior is lost, right? So at one hand, I cannot store the data. On the second hand, I cannot even keep the data. So I have to think about a platform which can keep the data and still run fast. And the fourth important thing is, it's not only about processing the data, it's all about scaling up the data and ensuring that the data is available for your, BI reports and BI teams to use. So how do you integrate your system with n number of HOTS product or n number of external products or external systems? These are the 4 questions that normally people ask when they try to solve a big data problem without a Hadoop-based solution. Now for us it's very easy, For us it's very easy because we know that whenever we want to try and search for a common platform which can store any kind of data, we know that Hadoop is the solution. Hadoop provides us with a data storage layer which can store any kind of data as you want. And when you store the data, Hadoop system is a scalable system, it's a distributed system. There is no way the data is going to slow down your process. So data is always going to be there. That's what's that's the first step. Second thing is, how do you process the data? If I have to, so I'll give you an example, guys. Let me give you an example. Imagine that I have a Shakespeare sonnet. You know, so guys, are you into reading Shakespeare and all? Yeah, no. Shakespeare sonnet are pretty big actually. So imagine that I have a Shakespeare sonnet, and I want to find out the number of times the word "the" was used in Shakespeare sonnet. You get the problem, guys? I have a Shakespeare sonnet and I want to find out the number of times the word "the" was used in Shakespeare sonnet. Business question understood, guys? All clear? Yes? Alright. Now what I can do is, imagine that there are 20 people in the class today. What I can do is I can have 20 photocopies of Shakespeare sonnet and I can give one photocopy to all of you. Make sense? Yes? No? I make photocopies of Shakespeare sonnet and I give one copy to all of you. Does it make sense? Guys, you there with me? Umesh says no, I didn't get it. So I make 20 photocopies and I give one photocopy to all of you. You all have the data now. It makes sense, right? Now the question is, if I give one photocopy to all of you and all of you take 20 hours to read the sonnet and come up with a solution, then let's say Subhas takes 20 hours and comes to me and says there are 2000 occurrences. Tulasi gets another 20 hours and comes to me and says it takes there are 2000 occurrences. In that way, I have to wait for 20 hours before getting a solution, right? But at the same time, what I do is, instead of me taking 20 photocopies of the same data, I can divide the book into some logical unit. Let's say the book has 20 chapters, so I divide the book into 20 chapters and I give one chapter to all of you. So guys, how long do you think it will take for you to go through one chapter? If the entire book took you 20 hours, how much time do you think it will take to read 1 hour or one chapter? 1 hour. So at the end of 1 hour, everybody of you will come back to me saying, okay, this is the number of times the word "the" was used in the chapter. All I have to do is take another 5 more minutes and aggregate all your data. And instead of waiting for 20 hours, I can wait only for 1 hour, 5 minutes and tell you that there are 20,000 or 2,000 occurrences of the word "the." So this is how we try to solve a big data problem by using distributed computing. So what we do is, we store the data into Hadoop, and now because we have tens and thousands of machines working together, we start processing the data together in a divide and conquer fashion. And now we have the luxury of processing the data in a greater speed, which nobody else can match up for us. And that is the reason when we talk about data storage and data processing, doesn't matter how much of data you have, doesn't matter how your data is growing in size, your data processing will always be great. Because when you know that your data is, let's say, you have 5 machines, and you know that your 5 machines are getting filled up, you can add on 10 more machines, and your size of the data will become, let's say every machine is 1 terabyte, and altogether you have 5 terabytes. If you add 10 more machines, you have a worth of 15 terabytes more. Now, that's not it. You're also adding up 10 more machines, and these 10 more machines will have their own RAM and CPUs. So your processing capabilities will also use or also increase exponentially. So your Hadoop platform provides you with a storage and computational process which can help you process the data. Now, somebody asked me, what do you mean by data premature death? So what happens in an example that I told you right now, a couple of minutes back, that in today's world, the credit card example, right? If I swipe a card, my transaction has to be matched with my pattern. Last 10 years, what was the pattern? If I do not have the pattern, then I do not know whether this transaction is a fraudulent transaction or not. In order for me to identify whether this current transaction is a legitimate transaction, I have to compare that transaction with my previous historical transactions. But the limitation with the traditional system is I cannot store traditional data forever in my traditional databases. I cannot store all my last 2 years, 3 years, 4 years worth of data in my RDBMS. I do not have that luxury. So, but if I use Hadoop, what advantage I'll gain is my Hadoop can store last 5 years worth of data, and whenever there is a new transaction happening, I can basically compare that transaction with the pattern of last 10 years, and I can understand whether this transaction is a legitimate one or not. So keeping the data alive is ensuring that you're not throwing away the data because of the limitation of the data, because of the limitation of storage. Naveen says loss of historical data or historical data not available to compute. Is it premature death of data? Yes. Premature death means you're throwing away the data, you're locking away the data, and you're not utilizing the power of the data for making your predictive analytics or making your future analytics. Example would be weather data. So tomorrow is going to be a sunny or a windy day. I can only understand if I compute the 8th of November data for last 10 years and understand whether last 10 years how was the weather like. Then only I can basically make a prediction by looking into my historical data. But if I do not have the historical data, throw away the historical data, I cannot make those decisions, right? And that's what I want. Can we not replace RDBMS with Hadoop? Not really. We cannot replace RDBMS with Hadoop. Why not? We're going to have a slide and discuss on that. And the most important thing with Vasu, the reason is we talked about a story, if you remember. We talked about why is Hadoop used and what are the use cases Hadoop is being used. Hadoop, guys, I'm repeating myself again and again. Hadoop is not used for providing a solution that is customer oriented. We're trying to make a business decision, and any kind of business decision we make, we need to store the data and analyze the data. So our Hadoop-based solution is only based out of analytical requirement. It is not a customer-focused requirement. We cannot replace an RDBMS because RDBMS is mostly stored with transactional kind of data, real-time customer-centric data. Here we're talking about decision-making analytical data. Right? Makes sense, guys? So far so good. Vijay says, if suppose there are 5 machines in Hadoop cluster and now I have 5 more machines in the cluster, then does the data distribute over 5 machines now restructure and get distributed over 10 machines? Good question, Vijay. Part of the question for now, we can only understand this kind of solution or the answer to this when you understand the internal architecture of Hadoop, right? So when you talk about internal architecture, you yourself can answer these questions, how the data gets distributed and how the data gets rearranged. It definitely does get rearranged, but how and when, you'll understand yourself when we talk about architectures. So guys, it's very important that you guys become architects. In Hadoop world, you cannot become developers because there is nothing to develop in Hadoop. Hadoop is working with all the same technologies that you are knowing for last 10, 12 years. It uses Java, it uses Python, it uses Ruby on Rails, and nobody can teach you Ruby on Rails in a couple of days. No, what happens is we're going to talk about and we're going to understand the architectures and the platform as a whole for Hadoop. This course is not a Hadoop, it's not a Java course. This course is not a Scala course. This course is a pure and pure Hadoop course, which tries to focus only on the architectural principles, the understanding of Hadoop, and how Hadoop gets implemented with one of these technologies. Make sense? All right. So what we'll do, guys, is another time or time for another small break. We'll take another 10 minutes break. When we come back, then we're going to continue from where we left off, and most importantly, we're going to get ourselves introduced into the nuances of Hadoop. Right. So we have been talking about big data. We have been talking about and understanding the big data-based problems. Now we're going to focus mostly on Hadoop-based solutions. So what is Hadoop? We have learned, and how is Hadoop created? What are the different components inside Hadoop? How is Hadoop structured? Everything is something that we're going to talk about right after this break. So guys, think about all the stuff that we talked about, all the use cases that we have defined, all the stories that we've told. In case you have any questions in your mind, please feel free and ask the questions when we come back. Okay, till 10 minutes, guys. Let's come back and continue from where we left off. So right now we're going to talk about the first thing that we are normally discussing in Hadoop world, that is the storage layer. We have talked about Hadoop providing a storage and a data processing layer. Right now our discussion is focused on the storage layer. How do we say that, or what kind of storage is associated with Hadoop, and how do you define the storage layer of Hadoop? Well, we said that this is a distributed system, and in distributed system we'll have 10 machines or 20 machines connected together in using a single networking layer, and we'll have all the machines working together in tandem. And whatever hard disk each of the machines will have, these will all participate in data storage for me, and that is what we normally talk about as data storing platform. Now, if this is so simple like that, the next question would have been, what is the difference between a grid computing and Hadoop? Because grid computing does the same thing. Distributed computing is not only unique to Hadoop. Distributed processing or distributed computing was always there even before Hadoop came into picture. So, what is so special about Hadoop? How does Hadoop provide a distinction that a grid computing doesn't provide, or what kind of differentiation in the data storage platform we are talking about here, which a grid computing will not provide? So the answer lies in a term which is called HDFS, or Hadoop Distributed File System. So what is Hadoop Distributed File System? Hadoop Distributed File System says, imagine that you have 20 nodes, and when you install Hadoop on these 20 nodes, then there is a service that gets installed on all these 20 nodes, and that service is called HDFS service, or Hadoop Distributed File System service. That service, nodes are nothing but servers, nodes are nothing but machines, nodes are nothing but instances. When we normally use these terms, frequently, in exchange of each other. So when I say nodes or servers or instances or machines, they're all the same thing. Okay. So when I say that I have 20 nodes and I have installed Hadoop on top 20 nodes, or when I say I have a 20 node Hadoop cluster, it means Hadoop has been installed on all the 20 nodes. Then there is a service that gets installed, and that service is called the data storage service, or HDFS service, Hadoop Distributed File System. What is that? What is so special about the service? The service, what it does is it installs an abstraction layer. It installs a file system layer on top of all the 20 nodes in such a way that when you log into any one of the machine, you feel as if you have logged into one single huge big machine. And at that point of time, when you log into Hadoop from any of these machines, you do not see the distinction of end of a particular machine and start of another machine. So for you, it feels as if there is no different 20 machines, but you have one single huge big machine together. So what is the advantage? The advantage is, in a grid computing, if you have physical identities of 20 machines, each machine having 1 terabyte disk space, you cannot save a file of size 2 terabytes, right? Because one machine has a limit of 1 terabyte. You cannot store a file which is bigger than the size of a single machine. You can store 20 terabytes worth of data, but every machine can store only 1 terabyte of data, and your single file cannot be more than 1 terabyte. But in a Hadoop distributed file system, because of this underlying Hadoop distributed file system, because there is an overall file system that gets installed on all the 20 machines in such a way that you lose the identity of each machine. Now whenever you have 20 machines and each machine, even though it has 20 terabytes, you can easily store one single file of 20 terabytes in that machine. So you lose that identity, you lose that definition that these are individual unique machines. Doesn't matter which machine you log into, all the machines, no matter which you log into, you'll feel as if there is one single huge big machine that is working as your single cluster machine or a single server machine. And that is the advantage of a Hadoop distributed file system. So you have all the CPUs, you have all the RAM, and you have all the hard disks collectively, cumulatively working together as a one single unit. And that's the beauty of Hadoop distributed file system. Now, if you install, if you add on few more machines in that, the Hadoop distributed file system will grow in size, and you do not get the distinction that okay, this is where my one machine ends and the next machine begins. Make sense, guys? What is HDFS? It's the underlying file system. It's the file system that gets installed on top of your actual file system. Normally, what do you have as file system, guys? If you talk about Windows machine, you'll have an NTFS. You will talk about Linux, you have proxy system. If you're talking about Mac, you have Max12 file system. But when you install Hadoop on top of 20 machines, you'll have another file system layer working on top of all the OS level file system, and that file system is called Hadoop distributed file system. And that file system is actually a service, and that service ensures that no matter which machine you log into, you believe and you feel as if you have one single huge big machine that is working for you. Now Sandeep says all nodes should have same hardware or it can be different. Theoretically it can be different, but normally traditionally, guys, nobody creates cluster which is heterogeneous. Heterogeneous clusters are very risky in terms of security, in terms of patches, in terms of upgradation. So I've never seen anybody using a heterogeneous cluster. Theoretically it is possible, but practically no, it should be all the same. If you have one single OS version, so another thing to tell you is Hadoop doesn't work with Windows, because nobody has a version of Windows. Windows anyways is a proprietary. It's not open source. Hadoop itself is open source, so you cannot be associating Hadoop with any other thing. So Hadoop runs with different flavors of Linux. It works on CentOS, it works on RHEL, it works with Ubuntu. These are the three major OS that Hadoop supports. So when you set up a machine, 10 node, 20 node, 100 node, 200 node, you tend to have a machine which is having homogeneous OS, homogeneous internet speed, and homogeneous machine definitions. And that is how you get a cluster which is working perfectly well. If you have a heterogeneous cluster, then the biggest challenge would be some of the machines will work slow, and if one machine in a cluster works slow, the slowest machine will become the bottleneck for your cluster, and you do not want to do that, right? So normally in any Hadoop solution providing, you tend to have a homogeneous cluster setup. Okay. So do you get it, guys? What is HDFS? Now, what is the advantage of HDFS? The advantage is exactly the same thing that you've talked about. If one machine which has 4 IO channels each IO channel can process 100 MBs per second, and if machine one machine can process a 1 terabyte file in 10 hours, then 10 machine can process 1 terabyte file in 1 hour. So you basically, what you do is you divide and conquer the problem, and you have 10 machines working together. It doesn't matter which machine you're logged into. When you save the data gets saved, and the processing gets executed in such a way that you process the entire 1 terabyte with 10 machines, and now you get only 1 hour instead of 10 hours to process the entire data. And that is the beauty of Hadoop. And that is possible only because the data gets stored into the underlying HDFS file system. Hari says, does the file has to be in the same network? Yes, obviously. You have to have all the machines working together in the same network. Otherwise, how it can be a cluster? All right. So any question, guys, on HDFS and what exactly it is? Any questions that you have? So HDFS is the most important component when you talk about Hadoop. It forms the underlying platform. It forms the underlying heart of the entire system. When you talk about Hadoop, HDFS provides the underlying framework how distributedness is achieved in Hadoop-based solutions. All right, so what is Hadoop? We have talked about it. If big data is the problem statement, Hadoop is the solution. So Hadoop is a framework that is built out of a lot of different tools and techniques collected together to form a single solution. It is an open source platform, and it is providing a solution to the problem which is tagged as big data problems. So we can categorize big data problems in 4 different ways: volume, velocity, variety, and veracity. If any one of or if one or more of this problem statement arises and we try to provide a Hadoop based or we try to put that as a big data problem, then Hadoop is one of the solutions that can solve the big data problem in efficient way. Sandeep says, how do we detect the system when the system fails? Well, we're going to talk about this, Sandeep, later on. Part of your questions, too early to answer. Only thing is, we'll talk about the architecture. When you understand and learn the architecture, we can understand and answer these questions. How to detect failures, how is failure tolerance maintained, how is availability maintained. All those questions can be answered when you understand the framework. All right, so Rajiv says Hadoop is little elephant. Well, I'm not sure if it's little or not, but it has grown tremendously over the last couple of years or 4 years or so. So Hadoop is definitely an elephant. The reason why it is tagged as an elephant is because elephants are considered to be very very intelligent, and that's what Hadoop is does. Hadoop does. It's intelligent and it is huge. Vinay says higher configuration machines should be added to an existing cluster, is it? Well, higher configuration machine, if you see, this is common sense 101, honestly, because let's say I have 10 machines. Now, if I have 10 machines and all the 10 machines have 2 GB RAM, suddenly I add 5 more machines that are having 10 GB or let's say 8 GB RAM. My processing, I'll tell you the same story, Shakespeare's sonnet. Let's say I divide the book into 20 equal parts and I give one part to all of you. For some reason, let's say Vijay, you have gone for lunch. So even though all of you are completing, getting me the number of times the word D was used in the chapter in 1 hour, I cannot find the final answer, right? I have to wait for Vijay to come back from lunch and calculate his own setup and give to me. So in a distributed network, the fastness of the entire cluster depends on the slowness or the slowest node in the entire system. So if I buy 5 machines that has 8 GB RAM, I cannot achieve anything with this 8 GB RAM because the 10 machines are working with 2 GB RAM. So I'm basically wasting my money buying 5 machines of 8 GB RAM because I have to wait for the response from these also to get the final response. So even if 8 machines or even if 5 machines process the data in 30 minutes, if these 10 machines process the data in 2 hours, then my final result can be achieved only after 2 hours. Doesn't matter if these 5 machines are free after 30 minutes, right? It's a common sense, right, guys? So when you talk about, forget about Hadoop. When you talk about any distributed network-based solutions, the machines are normally homogeneous in nature because the weakest link uh, in the entire network is the actual strength of that entire network. So Arun says 1 terabyte each node, 10 nodes, it means you can process 10 terabytes. Yes. So in HDFS, we do not say how much each machine has. We normally collectively say the HDFS has or can handle 10 terabytes worth of data. So in HDFS world, it is 10 terabytes collectively. You can have one file of 10 terabytes, you can have two files of 5 terabytes each, but collectively, the files that you are saving into HDFS can be, the total size can be the size of the entire cluster. Any limitations to HDFS? Well, there are no limitations to HDFS. And guys, when you talked about whether you can save any kind of data into HDFS, the answer lies in the name itself. HDFS is a file system, like your NTFS file system or your POXIS file system. Because it is a file system, you can dump any kind of data. You can dump a PDF file, you can dump a CSV file, you can dump a TSV file, you can dump a MP3 file. It is a file system, you can dump any kind of data in there. And that is the reason Hadoop is a framework. It's a platform that provides you with a storage layer where you can dump any kind of data. All right, so Vasu says how Hadoop is different from frameworks used in Netezza, SAP HANA, etc. Well, first of all, Netezza is a database compliance tool. And SAP HANA is a database and application tool. So SAP doesn't do anything. It is a cloud-based database. That's it. So Vasu, I'm not sure whether you asked this question just because you know the names of these components. Question, guys, is Netezza, SAP are nowhere related to Hadoop. SAP is an out-and-out in-memory database. It's in-memory database. Here in Hadoop, we have understood till now that Hadoop is not a database at all. It is a file system and it's a processing engine. So it is a file system and a processing engine collectively together. It's not a database at all. SAP HANA is only a in-memory database on cloud. Netezza and an appliance blocks all together. So what you do is you go to Netezza, they'll give you a box. Very, very costly, hugely expensive box, guys. I cannot even tell you the expense that your solution will have to suffer for that. Challenge is you cannot plug in another Netezza box. One Netezza box can handle a huge amount of data, and that's going to cost you fortune. It is not a distributed network or a processing platform like Hadoop. It is just an appliance box which has a very, very high RAM, memory, CPU, and hard disk associated with that. Yes, so whenever you talk about transactional systems, I talk about transactional systems. My Oracle cannot handle it. My Oracle, can only handle 1,000 events per second. But I need a system, let's say a Bank of America system that can handle millions of transactions per second. I do not need an analytical solution. Hadoop is an analytical solution, and Hadoop is not a database. I need a database that can handle that amount of transactional data. So what I do, I go into Netezza and buy that box, or I go into Exadata, or I go to Teradata and buy that database box. So these are database solutions. Instead of an Oracle, you can compare, an Oracle box with a Netezza. Yes, it is a big data solution. The reason why it is a big data solution is because we are talking about Oracle limiting itself to a certain volume of data. Netezza Teradata doesn't, limit itself to a volume of data. You can have any volume of data loaded into that. The difference between Hadoop and Netezza or Hadoop and Teradata is that Hadoop is a processing and a data storage layer for analytics. Netezza and Exadata, these are all database-based solutions. A solution which is like-for-like replacement for database technologies. Hadoop is not a database at all. We cannot replace a database with Hadoop. Hadoop is a data analytical storage and processing engine. It's only used for analytical purposes. Make sense, guys? Subhash says, when you use 50 nodes, it is like 50 into 1 terabyte. Yes. So when you use 50 nodes, it becomes a 50 terabyte HDFS cluster. Absolutely right. So do you have any question, guys? Net, what we are trying to say is Hadoop is not database. We cannot replace an Oracle with Hadoop. We cannot replace an RDBMS with Hadoop. Hadoop is an analytical based solution. It's an out and out analytical based solution. I have to provide a solution. I have to provide a analytical result, and for making an analytical result or analytical decision, I have to save some data. I have to identify and get my data into a platform. So Hadoop gives me a platform for loading the data, and later on I can analyze the data to make a decision out of the data. How are clusters connected if there are multiple clusters? Well, if there are multiple clusters, I'm not sure why you need to connect them. Cluster itself means a physical entity. Two clusters will be used for solving two different problems. One cluster can be used only for maybe HR based profiling. Another cluster can be used for something else. When you have two different clusters, invariably they'll not interact. If they want to interact, they'll be interacting with some kind of custom code. If you do not have a business case for clusters to connect, most importantly, guys, you do not even need separate clusters, because when I say cluster, it's a scalable thing. If I have 20 terabyte 20 node cluster, tomorrow if there is a new business coming in, I can add 20 more node and it can become a 40 node cluster. So clusters are physical entities. Normally, we talk about production clusters, then one company has one production cluster. Within that production cluster, you can categorize your cluster so that some part of the cluster can only address maybe financial questions. Some part of the cluster can handle maybe human resource questions, and in those cases we normally call it as a multi-tenant cluster. So these are all complicated terms we're going to cover up later on, but normally when I say cluster, this is an isolated individual component, and within the cluster all the machines connect together in a single unified format. Make sense? Hari says, does it mean we can have any number of nodes in a cluster? Absolutely yes. In Yahoo, we'll cover up later, there is a cluster that has 3,300 machines. So you can have an uncountable number of machines working in cluster. No limitation in that. Hari says we can keep adding nodes as the data size increases. Absolutely right. Subhash says, in general, a company has only one cluster that has multiple nodes. Yes, normally you have a development cluster, you have a production cluster, you have a UAT cluster, but yes, one production cluster only for one company. It depends on a company's policy. Sometimes the company, like let's say we're talking about Google. Now Google has been divided into Alphabet and Google. So maybe the holding company says, okay, let's separate out all those infrastructure decisions. So maybe internal to Google they'll have own cluster, internal to Alphabet they'll have another cluster, and all this stuff. So it depends on your company policy, but a general solution would be there is no limitation to the size of a cluster. So if your company has a requirement of 1,000 node cluster, you can easily make 1,000 node cluster, and everybody can use that 1,000 node cluster. Nobody has to be denied of anything. So you can easily do that. And imagine it, guys, this is only an analytical solution we're talking about. So 1,000 node cluster means that you're talking about analytical based solutions. And you're talking about 1,000 nodes which are used for solving analytical decision making capabilities. These are not customer oriented, customer focused solutions. We are not talking about a web service, a web application, or a POS system. It's not a point of sale which is generating the revenue. It's an analytical system where you can collect the data, analyze the data, and you can understand your company's clients better, your customers better, and help make decisions of your business. All right. So what are the key characteristics of Hadoop? So it's reliable. So we talk about reliability, but one thing is sure, Hadoop is very reliable. Even though Hadoop is created out of commodity hardware, it's highly reliable. There is no failover in Hadoop. It's always failover tolerant. We'll talk about failure tolerance when we talk about the architectures. But from an overview, you can see that Hadoop is totally reliable. It has an inbuilt reliability and failure tolerance built into it. It's economical. Why is Hadoop economical? Guys, can you tell me why is Hadoop economical? Give me the word. We have used this word so many times. Open source, yeah, open source, but nobody uses open source. That's another story we're going to talk about. Another word, guys. What makes Hadoop, economical? Mohammed says cheap servers. Cheap servers, yeah, but we use a term, we use a term, commodity hardwares, right? So normally you do not have to use server-based hardwares. You are not entitled, or you are not supposed to use very expensive machines. Commodity hardwares will work wonders for your cluster. Even companies like Google and Yahoo have been using commodity hardwares. No license cost. That's a far-fetched talk. We'll talk about this. Hadoop comes with a cost, of course, but that's a different story. We'll talk about that. And flexibility, Hadoop is very, very flexible. We have seen why is Hadoop flexible, because of underlying HDFS. The underlying HDFS is a file system. It's flexible because the file system can store any kind of data as you want. The reliability, economical, and flexibility is something that is built on the internal nuances of Hadoop. The fourth thing is scalability. I have a story for this to tell you. So guys, can anybody tell me a summer of 2010, a cricket match in Gwalior? What was so special about it? Anybody, guys? I'm sure a lot of people will be following cricket. Anybody, guys? Can you remember the day? A summer in 2010, Gwalior. What was so special about it? Sandeep says 200 by Sheva. Not really. Arun says 200. Sachin. Yes, absolutely right. Arun is spot on. 200. The first cricketer in this entire world to score a 200 and ODI. Now, Sachin's 200 is obviously important for emotional reason, but for Hadoop world, the most important thing is if somebody has gone into the Cricinfo site. So there is a site, guys. All of you who do not know, there is a site for viewing the scores, and it gives you a minute by minute update. And it's called Cricinfo site. A lot of people who are working in the office do not have the luxury of viewing the match. They'll basically log into the Cricinfo and see that data. So what happened on that day is, Sachin's 200, Sachin's score was nearing his 200. There were so many people logged into Cricinfo. The Cricinfo crashed. Cricinfo crashed because of it couldn't handle that volume of the data, or volume of users logged into the system. The traffic was so huge. And then within 10 minutes, Cricinfo came back up again, and they apologized for what has happened, said we never predicted that amount of data, and now we are good. So how do you imagine a company whose production has crashed for the volume of data could come back up in 10 minutes and get a better infrastructure ready so quickly? Do you think it is possible, guys, for anybody, any traditional system, to come back up again and have more data loaded up in your system with respect to hardware and infrastructure so easily? Muhammad says cloud. Yes, cloud is one of the solutions. The answer is scalability. When you talk about Hadoop, when I talk about Hadoop-based solution and cloud goes in hand in hand. And you can increase the size of your cluster for 10 nodes to 100 nodes with respect to in minutes. Trust me, guys, I've seen people who have expanded or scaled their cluster from 10 nodes to 20 nodes to 30 nodes to 40 nodes in minutes, and that's what you get from Hadoop-based solution. If I tell you another story, the reason why people are talking about scalability is, and why it's so important. Imagine that you guys have a gift shop, an online gift shop. The online gift shop runs on 3 nodes, and it runs pretty well throughout the year on 3 nodes. Now you know that at the starting of December, Christmas time, you're going to have a lot of hits in your gift shop, and you know that this is a time where you might have to think about increasing the load of your system. So what you do is you scale up your cluster and have a 5 node or a 10 node cluster only for the month of December to January. After the end of January, again you scale down the cluster and you basically keep on using your entire setup for 3 nodes to work with your entire gift shop. The advantage is, because I'm talking about scalability, because I'm talking about ramping up and ramping down my infrastructure, I do not have to waste money on holding up to 7 new resources throughout the year. I know that only for the month of December and January I'll be requiring infrastructure. I'll be getting that up only on that month. Remaining 10 months, I can still rely on my 3 nodes and I can have my business working fine. And for the remaining 10 nodes, I'm saving a lot of money on my infrastructure, and that's what Hadoop provides you. You can scale up, you can scale down your system, your cluster anytime you want in minutes. And that is the advantage you get when you talk about a cloud-based solution. Make sense? All right. So this is the last slide we're going to talk about, guys, and a very important slide with all the discussions we did. In almost 3 years we have been talking, or 3 hours we have been talking about Hadoop and all. Now this is the time for us to understand what is Hadoop actually doing. What is the difference between Hadoop and RDBMS? Is Hadoop actually doing something that RDBMS does, or is Hadoop replaceable by RDBMS? All the questions that we have already answered, we're going to categorize them into this slide. All right, what is Hadoop? One second, guys. Sorry, okay. So first thing is, RDBMS works with structured data. It talks about transactional data. It has to have a schema. It has to have a particular structure to the data. Hadoop, it is an analytical solution. Hadoop doesn't have to worry only with structured data. And you have seen that in today's world, data is not only what is available in your RDBMS, 90% of the data is actually collected over the web. So we're talking about multi-structured, unstructured, and polystructured data in Hadoop. Hadoop deals with any kind of data. Because it is based out of HDFS, Hadoop Distributed File System, it's a file system. Hadoop can handle any kind of data, any structure of the data, any extension of the data. RDBMS is strictly a process, strictly a schema-based solution because we're talking about transactional data. So data types totally different. Hadoop and RDBMS totally miles apart. Processing. RDBMS doesn't have any processing tool built in. There are some. If you're talking about Oracle, you can have a PL/SQL block, you can have a function and a procedure written. If you're talking about DB2, if you're talking about MySQL, they have very limited to no data processing capabilities. Hadoop, well, we cannot be entitled only with data storage. We have to talk about data processing as well. The reason why we store the data is because we are processing the data. So Hadoop provides a end-to-end data processing capability, that too processing any kind of data. Governance of the data. Well, data governance in Hadoop, in RDBMS is huge. Why? Why you talk about data governance? Data governance means when you have a table created, let's say I have a transactional table, I have swiped my credit card. That credit card data has to go and fit into my table. So every time I insert a data into RDBMS, the data is validated, whether it's a correct data or not, whether it has all the processes or not, whether the data type is correct, whether the data governance is correct. So Hadoop, when I talk about RDBMS, there is huge governance on the data when the data gets saved into HDFS. Oh, sorry, data gets saved into the tables. What is the advantage, guys? What is the advantage of data governance? The advantage is I'm ensuring that no corrupt or no incorrect data gets saved into my RDBMS. But the flip side is, if I have 1 million transactions happening per second and every single transaction has to be validated before the data gets inserted into the table, there is a huge latency involved in saving the data. So RDBMS talks about data governance. It ensures that correct data gets saved. Hadoop doesn't mind it. Hadoop says there is no data as correct, there is no data as incorrect. Whatever data you have, just dump the data into HDFS. Later on, we can process the data, and while processing the data, we'll check out the importance of the data. So we'll do an ETL process later on, but right now, save any kind of data you want. So there is no governance of the data in Hadoop. Schema, RDBMS is schema on write. Every time you write a data, every time you insert a data, the data gets checked. If you're trying to insert a string on a double table type, then it's not going to allow you to save the data, right? So when you talk about RDBMS, the schema is validated. Every single insert, the data is validated. Hadoop, well, there is nothing called schema on write. Every time you write the data, you can dump any kind of data, you can write any kind of data. Only when you read the data, you can write your own pseudo logic to identify what kind of data you want to read. So in Hadoop-based system, there is no schema associated. The schema is associated only on the RDBMS side, which ensures that correct data gets saved into your actual tables. Now, because of that, the reads are fast in RDBMS. The writes are very slow. The writes are slow because every write has to be validated. In Hadoop, the writes are super fast. Well, you cannot compare the reads because in Hadoop you are reading terabytes of data. In RDBMS you are reading only gigabytes of data. But from the data storage perspective, RDBMS is very slow because we are validating the data. Hadoop you can dump terabytes and petabytes of data very smoothly because you're not validating against anything. The cost, well, RDBMS has definitely cost on the solution software. Hadoop doesn't have it. The reason is different. Let me explain that. So normally, Hadoop is managed by Apache. Apache is an open source. Apache is a it's a company that basically has provided Hadoop open source. But tell me this, guys. Do you think there is any company in the world which can move into production with the open source technology? Is there any company in the world which can allow you to move into production with the open source technology? Are there any companies, guys? Do you think your company will allow you to move into production with the open source? No, right? So Hadoop software is open source, but there are so many vendors in today's market. Cloudera being one, Hortonworks being another one, IBM Big Insight being another one, EMC being another one. There are so many different vendors available. All the vendors, what they have done is they have taken the open source version of Hadoop from Apache and they have packaged the entire solution as a product, and they cannot sell Hadoop as a product, but they sell only the support as a product. So they say, take Hadoop and the package solution from us. Cloudera has their own solution. Internally they use the same Apache. Hortonworks have their own solution. Only thing is you buy the support. So Hadoop has a support only cost. You buy the support for production. You do not buy the software. But for RDBMS you have to buy the machine, you have to buy Oracle, you have to buy the license. Everything comes with the cost. When you talk about resources, well, it is a known entity. You get a lot of resource right now into RDBMS. Hadoop-based world is growing complex and wide. Things are complicated. Because of all those differentiation, guys, because of all the things we have talked about till here, what do you do? What conclusions you can draw? The conclusion you can draw is because of the structured net of the data, because of every time you are inserting the data, you are validating the data, because every time you are writing the data, you are checking the data, because of the structuredness of the data, because of the governance of the data, RDBMS is working wonders. RDBMS works with all kinds of OLTP based solution offering. When you talk about OLTP, it's online transactional processing. Any kind of transactional database at the back end of the system has to be Hadoop based, has to be an RDBMS solution. You cannot replace an Oracle with Hadoop because RDBMS provides you with all the complicated OLTP solutions, which talks about the ACID properties, atomicity, consistency, identity, and the durability of the data. So whenever you are talking about an OLTP based data solution, you are talking about RDBMS because you need all the features. But because of all the features that you talked about, use Hadoop as an OLAP system. You're talking about online analytical processing system. Any kind of analytical system, any kind of analytical database, any kind of analytical data model you're going to talk about, you have to implement that with Hadoop. So Hadoop is a strictly OLAP based solution. RDBMS is strictly OLTP based solution. And there is a huge difference between the two. So you cannot replace an RDBMS with Hadoop. You cannot replace an Hadoop with RDBMS. Both of them coexist and try to provide two different solution offering to all different use cases. So wherever the use case is available which requires you an OLTP system, you have to think about an RDBMS solution. Wherever you are talking about an OLAP system, you are talking about a Hadoop solution. And these are two different individual distinct identities. Make sense? Vasu says, can you also briefly touch upon how we use Hadoop impact existing data governance structured in our organization? Well, data governance is very important, right? See, what do you mean by data governance? So data governance is a vague term, and normally you use data governance with respect to terms like data profiling, data identity, data management, compliance testing. A lot of different things comes under data governance. Uh, so, uh, you know, uh, in US actually, honestly speaking, in US, you might have seen for last 1 year there have been so many companies, violating the data governance issues. A lot of time people have been saving the data into the databases without proper masking, without proper, there are so many compliance issues with the data. So what do? You have terabytes and petabytes and zettabytes of data saved into your entire, business, business clusters. Now you need to identify whether there is some kind of, data that you are not supposed to save. Is there some compliance issue with the data? Is there some masking on the data that you need to have? So these are all kind of use cases where you need to do a governance of the data using Hadoop. Because if I see at the end of the day, it all boils down to the same thing. If I have 1 petabyte of data, and if I do not have a Hadoop solution, if I have just a Java solution or a .NET solution, if I run a .NET program, and the .NET program has to process 10 petabytes of data, it will take you ages to process the data. Do you agree with me, guys? But when I have to search something, I have to do a data governance, or I have to do a data cleansing, or I have to do a data profiling, then at the end of the day, I need a system that can parallelly process it. If there are 5 petabytes of data, I need 5 petabytes to be processed at least in 1 hour, right? Then only I can do something. If I run some process and it takes me days to end the process, what is the advantage I'll get? And that is the reason we talk about Hadoop-based solutions when we have huge amount of data and we want to process the data. So governance and all these things comes under data analytics. Why? Because somebody is storing the data and you want to find out whether it is breaking some kind of compliance issue, or is there some kind of governance on the data that you are supposed to search with. So that is why, that is where your data governance comes into picture. And when you talk about, so Vasu also said data ownership, data quality, lineage, stewardship. See, these are all terms that you associate with the data. Lineage means who is using the data. So these are all corporate level questions that people start questioning when they start using certain processes. Let's say I have a financial report coming in every day, and I save the financial report into my HDFS, one of the folders in HDFS. My question is, is this data, because this data is available in HDFS, does it mean that this data is accessible and can be accessed by everybody? If somebody is accessing the data, do I have a lineage of identifying who is using the data? Why is this data used for? Will every time I'll be using the data? So these kind of questions comes into your lineage factor. Who is using it? How it should be using it? Should there be a restriction of how the data should be used? All these are the factors that we normally talk about. Right? So normally when you talk about Hadoop, all these things come into picture. Data quality, data stewardship, data compliance, data governance, data lineage. Because now you have a platform where people are dumping the data. Now the question will arise is who should use the data, how the data should be used, should you have accessibility to the data, do you have read-only permission to the data, or somebody does have an ability to change the content of the data also. All these questions come up, and for this, it is not about Hadoop to answer this. This is all about the data architecture to answer this. So that data architect in your system will basically envisage the entire problem and provide a solution about who should proper utilities of the data should be, or who should be using the data, how the data should be used and all. Make sense, guys? Alright, so this is where we're going to end for today's class. If you have any question, guys, you can still have a couple of minutes for answering questions. But mostly our class today was talking about identifying what is Hadoop, what is big data, what is the difference. And right now we have reached a conclusion where we understand why is Hadoop used for and how should Hadoop be used for. Make sense? Any questions? Alright. Okay, guys, if you do not have any other questions, this is where we're going to call it a day. Guys, when you complete this, Arun says if 10 nodes are processing and if node fails, well, as I said, we are talking about reliability of the entire cluster. The reliability is internally maintained. How is the reliability maintained? How is the fault tolerance maintained? We can only understand when we talk about the architecture. So internal architecture is something we're going to talk about, but we can only talk about architecture when you know the things, inside out. Okay, so we are approaching that state where we know what needs to be done, and then we'll talk about the architecture. So these are the questions that you should basically park for right now. But always remember the question, guys. When you talk about those topics, please ask the questions. We'll get the clarity. Do you get any pre-work for tomorrow? Well, this is, yeah, we do not have any pre-works, any homeworks in these classes, guys, because this is the class normally used for working professionals. We all know that you guys are busy. Only thing that we can talk about is, if you're coming to a class, next class, if possible, just, if that is at all possible, just revise the things that we talk about for 30 minutes, and that's it. Um, So Arvind, your questions about multiple copies of the files and all, we're going to talk about this. It's not multiple copies of the file. There are certain things available for reliability. We're going to talk about it later on. Okay, but yes, your questions are valid. We'll get them clarified easily. Suhas says, do you get any support for Hadoop certification from Edureka? Well, uh, officially there is no support like that, because the certification has been provided by Cloudera or Hortonworks, but the course here is created in such a way that, trust me, whenever you appear for a certification, it will help you tremendously in those certifications. The course is actually design model with respect to the kind of questions, the kind of processes Cloudera uses for their own certifications. Right? So this is a good start, but trust me, guys, 30 hours is not enough for doing a certification. After 30 hours, is only going to enable you to be self-sufficient in learning, understanding, and working with Hadoop. So after that, the onus is on you. You have to bring this, take this forward, learn yourself, and get more experience into Hadoop as a Hadoop solution provider. Which certification is more valued? Well, I cannot comment on that. I have a Cloudera certification. A lot of people are also doing Hortonworks certification for Hadoop. So yes, a lot of certification. All of them point to the same thing, guys. There is no difference. All of them are more or less the same thing. All right. So certification is, I'm not sure in which sense you're asking, because people talk about certification because they want to get a feeling that they know certain things. So that's the only reason people do certifications. I don't see that somebody will use a certification to value you whether you know Hadoop or not. That is something for your own satisfaction. So that's how I believe it. Apart from this course, what else to be done for the certification? Well, for the certification, honestly, if you ask me personally, I would say project experience. If you have good 3-4 months of experience, that's the best thing you can do. Because this is a 30-hour course. 30-hour is actual good, process to get you started. But apart from that, 30-hour is just an introductory course. Honestly, you have to take it forward from there, because 30-hour is just to enable you to understand Hadoop. Remaining is something that you're going to talk about or learn on your own in business and in projects. Make sense? What about practical assignments? There are two different ways, guys. There is no practical assignments in this case, because there is no way I can validate those practical assignments. But what happens is, after we complete a module, there will be certain, in-class practicals that I'm going to show you. So I'm going to do certain practicals, and we're going to, involve the class. I'm going to complete an assignment. Every module we complete, we'll do a couple of examples of that, and that examples will help you to think about how things get done in actual world. So this is the way. But after I do the examples, and after you go back to your after you complete the classes, as I said, it's totally on you. You can practice as much as you want. At the end of tomorrow's class, and I'll tell you that there is a PDF you can use, and that PDF is going to tell you how to set up your own small setup to practice stuff. So the more you practice, the more confident you get. And second most important thing, guys, is in this class there are a lot of people coming from non-programming background, a lot of people coming from project management background. They want to only get a value of the understanding. So we cannot basically force everybody to have to code something, because a lot of people come and learn Hadoop for different reasons. Some to become developers, some to become a solution architect, some to understand the reason why, or basically talk to the clients. So in that way, every program, every module you complete, we're going to have a small demo, and after that, you guys can practice on your own. The 10th module is an assignment given by Edureka, and you can complete that. That's not a very technical, assignment. That is a write-up an assignment, and you can complete that assignment. You can submit that to Edureka, and they'll give you a certification of completion only after 30 hours. And that's how the course is designed here. Make sense? Do you have a VM to practice? Yes. How to download the VM and set up the VM is something that I'm going to have a 2 minutes session tomorrow. Apart from that, there is also a AWS component. So there is an inbuilt setup for you. You can log in and start working on that. And then a lot of people are facing issues setting up the VM. For that, you can write to Edureka support. They're going to have a total screen sharing session, and they can install the VM for you also. So all these are supported for you. You don't have to worry about it. Everything is being managed. So you'll have a platform to support to practice, and you'll also have a online a portal where you can also go and practice. If I need to practice with programming as well, so I'm not getting the questions. If you're asking about if you have to learn Java, well, if you have to learn Java or learn Python or learn Scala, then this class will not support it, because it is this course expects that the prerequisite is some of these programming languages. But then again, as I said, Hadoop is not about programming only; it's a platform. There are people who come from Oracle background, and they find a lot of different components and tools to practice in Hadoop. Hadoop is actually a entire platform. You need programmers, you need architects, you need data scientists. So all of people come together and work with the Hadoop solution. So if you're comfortable and confident with some part of Hadoop, you can start with that. Programming is not a mandate. Till when you can use VM? Well, VM is available for you throughout your life. Well, VM is actually a virtual machine that you install in your laptop. There is a remote machine also, a remote setup. The remote setup is available throughout your life. So you can have a username, password. You can log into that remote setup, and you can practice it all through your life. So that's a possibility. Which is most used? Java, Scala, and Python. Again, as I said, there is no, to each one is its own. Hadoop is not restricted to any kind of programming language, guys. Hadoop doesn't say that you need to use programming language. Hadoop says it's a platform. If you know some language, you can use that language. That's it. So there is no advantage or disadvantage of using any languages in that way. Whatever you're comfortable with. All right. Okay. So any more question, guys, on this? I've installed Oracle VirtualBox. Is it enough? So Oracle VirtualBox is a way to open up a VM. So Oracle, on top of Oracle VirtualBox, you have to set up a VM. You have to download the VM. So you need two things, a VirtualBox and a VM. So VirtualBox is a player, and VM is the VM. Arun says, I have only core Java knowledge. Will it be enough for a developer? Honestly, no, because for Java, for writing a distributed programming, you need to have a very deep, in-depth knowledge about a lot of different stuff. But I mean, you can learn that. That's what I'm saying. If you're talking about only core Java, it might not be enough. But you can learn. If you have the basics right, learning something is very easy. What books do you suggest for Hadoop? Well, there is a book called Definitive Guide. A Definitive Guide, Volume 3 or Edition 3 is considered to be the Bible of Hadoop, and that's a good book to start off, right? So yes. So do not get worried, guys. You start off with something and you end up understanding that yes, it's so easy. First steps are always the hardest, and you guys did the right thing in taking that first step and attending the course. It'll be easier for you now to move ahead. Okay. Subhash says, if you get a project environment, what are the important aspects to explore and practice? Well, I'm not sure about the question, Subhash, but as I said, if you are thinking again from a developer's point of view, if you get a project, it's not only about writing a particular pieces of code. It's not like that. Hadoop is all about the platform, so it is not about practice. It's all about the architecture. It's all about understanding part of it. Umesha says, I love coding and development. How can I improve with this? Honestly, I knew that. I wish I knew the answer to that, Umesh. As I said, Hadoop is not for, it's not a, development and coding platform. Yes, you need to write some kind of data analytics. For writing the data analytics, you can use your own existing coding skills. Hadoop is not going to teach you a new programming skill or a coding skill. So in that way, if you ask me how I'm going to develop it, you develop your coding skills just like the way you want to develop any other skill. Practice, learn. But Hadoop doesn't say that you need to learn something like that. Hadoop says your goal is to implement a predictive analytics. For implementing predictive analytics, you have to bring your own algorithm. How do you code your algorithm? Which language you use to code your algorithm is up to you. Hadoop says if you write your algorithm, I can use a distributed computing model to give you the flexibility of running this over the entire network. So Hadoop doesn't say that you need to write your algorithm this way. Hadoop is not an algorithm-based solution. Hadoop doesn't provide you with any kind of algorithms. Hadoop only provides you saying that I can provide you with a distributed process or a framework. After you get the framework, you can write your program like the way you have been writing your program all these days. Srija says, I'm a fresher and I don't have experience. Do you suggest me to learn additional apart from this class? I'm comfortable with today's class. Uh, well, as I said, Srija, I'm not the best person to tell you what should you learn. But yes, if you want to learn something, see, everything you learn will come into play someday or the other. And that happens always, guys. There is nothing that you need to, that you learn and you feel bad about learning it, right? So it's a process, and people learn a lot of things. In Hadoop, you need to learn, you have to have experience in programming. Hadoop is not going to teach you anything about programming. So you have to bring your own programming experience. You have to bring your data analytics experience. You have to bring your own infrastructure experience and networking experience. If you do not have, the point is, you are on the correct path. You're going to learn this as you go and implement projects and learn about Hadoop. So Hadoop is a combination of all these things together. Is there any relevance to Hadoop and Tableau? Yeah, Tableau is a BI tool. Hadoop is the underlying framework. If you want to analyze data and visualize the data, and if the data is huge, then you plug in your Tableau with Hadoop. When you will get this recording in LMS? The LMS recording will be available in 24 hours, guys. So net, guys, what I understand is all of you are pretty much, apprehensive about how do you program something, how do you write something. Guys, trust me in this, programming is only maybe 5% of what Hadoop offers. Hadoop is very, very bigger, broader than a programming framework. Programming is a very small word to use, honestly, uh, when you talk about Hadoop. Now, Hadoop is a platform, and I'm not sure, people who have worked with the platform will vouch me for this, saying that programming is just 5% of it. Or programming is just implementation that you can do in Java. When you talk about Hadoop, nobody talks about how to implement it, because you get some Java developers and say, okay, you implement it like this way. But other than that, when you talk about Hadoop, when you want to become a architect, that's how you become an architect in Hadoop. You normally understand the entire things and all the working parts together and see how they fit together. What does a Hadoop developer do normally? Well, there are different types of Hadoop developers, guys. That's what I'm saying. A person who comes from Oracle, he will have a lot of data-oriented programming process. He knows how to write that, how to write database. Say at the end of the day, it doesn't matter, whether, let's say, I have to, add up two things, A plus B is equal to C. Doesn't matter if you write a Oracle program, if you write a Java program, if you write a Python program. Nobody gives a huge, it's not a huge challenge, nobody actually gives a huge thought about it, which programming language you should use. Because Hadoop is not talking about how to add A plus B is equal to C. Hadoop doesn't tell you that you need to add A plus B and get a result C. That is your business. Your business says that somebody is giving you a data called A from a source, somebody is going to give you a data called B from a source. You have to find out different ways of how do you store a data A and a data B together in HDFS. How do you bring the data from external world? How do you channelize the data and instrument the data and put the data together? Now, once you have the data A and the data B, now you have to add this data together. You use Java to add it, you use Python to add it, nobody really cares. And Hadoop doesn't say that, I'm going to teach you how to add A plus B. No. Hadoop doesn't even do that part. Hadoop says, you know how to add A plus B, you just add it. So you add A plus B. And when you get the C value is stored into another place, and then you have another BI tool saying that, okay, now you have C, I can display the C to my management screen. So how to plug in a third-party BI tool, how to have an external system connect to your HDFS and get the value of C and display it. These are the things that you're going to talk about. how to build a platform that can support A and B, how this A and B can be combined together, what kind of infrastructure that you need to sum up A plus B together in parallel. And then if you have A plus B joined together, how to save the data C and have the data C available to your external world. These are the questions you're going to answer with Hadoop. You're not going to answer how do I add A plus B, which language. This language has not been answered by Hadoop guys. This language is answered by all the programming languages. How does the Hadoop develop? Okay, so will this course cover how to handle relations in Hadoop? Well, there is no relation in Hadoop, right? When you talk about unstructured schema-less data, you do not talk about relations in Hadoop. In Hadoop, we talk about ETL processes, we talk about pre-processing, and we talk about processing. And this course is going to talk about processing, pre-processing, and ETL processes. All right, so we're going to talk about we're going to talk about a lot of different products. Uh, Subha says, what is Splunk? Well, Splunk is another framework. When you go into Hadoop, apart from the core niche technologies, there are a lot of third-party tools available. Splunk is one of those tools used for actually data processing. So there is a framework used for data processing, and that's called Splunk. So Splunk is actually not covered by us because Splunk is not Hadoop-based solution. It is third-party solution. Somebody wrote something called Splunk, and few of the people use it. We'll be mostly focusing on MapReduce. MapReduce is a programming model. It's not a programming model, it's a programming framework actually. So we talk about Flume for ingestion, we're going to talk about Scoop, we're going to talk about Hadoop APIs, we're going to talk about Yarn, we're going to talk about Uzi, we're going to talk about HBase, we're going to talk about MapReduce, we're going to talk about Hive, we're going to talk about Hue. These are the components we're going to talk about, and these components are actually the core components of Hadoop. All right, so Kanti says in Hadoop does data needs to be flattened. So data doesn't have to be flattened. But anyways, guys, I think we're going too far ahead. What kind of operations you do in Hadoop is something that we're going to talk about only when when we cover up all those details, right? For now, net important thing is, guys, we know what is Hadoop, we know what is big data, and we know the difference between Hadoop and RDBMS. Is that correct, guys? Is that understanding correct today? That we know the differences, when to use Hadoop, when to use RDBMS, and all the differentiations connected to that. Vijay says we're going to learn Zookeeper. We're not going to learn Zookeeper. We're going to talk about Zookeeper because Zookeeper is an orchestration service. It's not a Hadoop service. We're going to talk about how Zookeeper uses or how Hadoop uses Zookeeper. That's what we're going to learn. Okay. So all this stuff and much more, guys, planned up for the next another 27 hours to come. All right. So stay tuned, and in case you have any questions, feel free ask questions, and we'll get all of them clarified for sure. All right. At the end of the course, guys, you'll get a pop-up. This pop-up is going to tell you about completing a feedback form, and your feedbacks are important for us, guys. So feel free and provide your feedbacks. All right. So with this thought in mind, have a great Sunday, guys, and take care. And we're going to talk about again tomorrow. Till tomorrow, guys, have a great time.